The first topic is indices and proportionality. And for indices, the objectives demand us to recall the laws of indices. These laws are very simple. First, we have this one here, x to the power of a times x to the power of b equals to x to the power of a plus b. Then for division, the same thing, but we are now subtracting the powers. Then next we have x to the power negative b, which is same as 1 over x to the power of b. So this one is important, we need to recall it. Then we have x to the power of 0, which is 1. So we know this one, any number to the power of 0 is 1. Then we also have this one here, x to the power of a in a bracket to the power of b is same as x to the power ab. So this one is not a problem. Then we also have this one where we have x to the power a fraction, and if we have a situation like that, it simply means that our denominator, we put it here, then our numerator comes and become the power of either everything like this or power of this one under the square root sign. Okay, so this is just recalling what we know from O-level. So that's all we need to do for now, but we're going to meet these ones in our next topics, and we're also going to do examples. So next we can move on to variation. Variation and proportionality is just the same word, or at least in terms of maths, it's just the same word, so we don't need to worry there. We just need to recall the types of variations. We have 4 of them. The first one being a direct variation. So a is directly proportional to b. It simply means a is directly proportional to b. Then if you want to remove this proportionality sign, you simply put equals and a constant k. Then next we have inverse proportionality, where we have a is inversely proportional to b, and we write it like this: a inversely proportional to 1 over b. Then if we are removing our proportionality sign, we have a equal to k over b. This can also be written as a k times 1 over b. Is the same thing. Then we also have joint variation. Joint variation involves our a being proportional to more than one variable. So we have a being jointly proportional to b and c. Here it's a c squared. So we have our proportionality sign, then b times c. Then we also do the same thing as direct and inverse. Then we have partial variation, where we have a being constant and partially varying with b. So this is the arrangement. This one is not very common in our A level. What we are going to find most is the inverse and the direct when we are now doing the differential equations. So just need to remember all these ones here. We are going to deal with them in details later. So we are done with indices in brief, so we can move on to logarithms. All right, so we are looking at logarithms now. So before we get started with logarithm, we need to be able to define what exactly a logarithm is. By the way, a logarithm is only valid for numbers that are positive real numbers. You cannot have a logarithm of a negative number. So it's supposed to be logarithm or something that is positive. So given x to the power of a equals to b, it simply means we have log b base x equals to a. Then I have an example here. We have our log base 10 of 100 giving us 2. Then we also have our log base 10 of 10 giving us 1. So in simple terms, a log of a number is the power to which we can raise the base together number. So that's simply what a log is. So we can move on now and start doing something with this information. So next we have what we call a natural log. A natural log is log base of e. This e is a new concept that we don't know from O level, but we don't need to care about where e comes from and stuff. Just take e as a number like pi. You know pi, so just take e as a number. E is equivalent to 2.718 something. So just take e as it is and move on. So like I said, this natural log is log base of e, and we don't write it like this. We simply write ln. So we use ln for this, which we refer to as ln. Then we also have laws of logs here that we can simply recall from O level. We have log base a x plus log base a y, same as log xy. Then if we are subtracting, we are dividing here. Then log a to the power of x, we simply take this x to the back here like so. Then if the base and the number equal, the log is 1, because we are saying that we are raising the base with this one to get this. So it makes sense there. Alright, so now let's look at the linear law. So the linear law is used mostly when you want to model experimental data graphically. For instance, if you have two variables x and y and you suspect that they have a relationship like this, you would measure your values for y and your values for x. After that, you're going to rearrange your equation like this using the natural log. Apply your ln both sides. Then in this one, we'll split into these two according to the laws of logs. Then this 2 is going to come to the back, and this 3 is also going to come this side. Then we have something like this. Then we divide everything by 2. We're going to remain with ln y equals to 3 over 2 ln x and half ln b. So this is now in form y equals to mx, which is the general equation for a straight line. So which means you're going to have a straight line, and if you have a straight line, you can find your gradient and your y-intercept. So what we have now is our y is going to be ln y, our x is going to be ln x, and then our c is going to be all this one here. So which means you can calculate your x, your b, and your y. So this is where the linear law works. There's an example on linear law, so we are going to meet it right after this. Alright, so now that we're done with the notes, we can look at some of the examples from those topics. So number one is from June 2003, paper 1 by Zimsec. The question says solve the equation. So our equation is equals to e to the power of 3 minus x equals to 2e to the power negative 3x, giving your answer exactly in terms of logarithms. So let's approach that one. We have got e to the power of 3 minus x equals to 2 e to the power negative 3x. So the approach here is to apply the ln both sides. So we are going to have ln e to the power 3 minus x equals to ln 2 e to the power negative 3x. Then next, this one can become ln 2 plus ln e to the power negative 3x. Now we can use the laws of logs, where we have our 3 minus x coming down and having our ln e equals to ln 2 minus 3x ln e. We know that ln e is 1 because the base of ln is e, just like we said in the laws of logs. So here we remain with 3 minus x equals to ln 2 minus 3x. So we take that 3x to the other side, and we are going to remain with the 2x equals to, taking that 3 to the other side, we have negative 3 plus ln 2. So our x equals to negative 3 plus ln 2 over 2. So this is our answer in terms of logs. Alright, then we move on to our next example. This example is from June 2010 by Zimsec. So the question says a mathematician working with an exponential relationship y equals to a b to the power x reduced it to a linear form and came out with the graph shown in the diagram below. So this is that linear law that I was talking about on top. So the question says state the label on the axis. Okay, so we are given y equals to a bx. We are given y equals to a b to the power of x. So let's make it linear by applying ln both sides. So we've got ln y equals to ln a bx, which gives us a ln y equals to ln a plus ln bx, which is a ln y equals to ln a plus x ln b. So rearranging this, I've got ln y equals to x ln b plus ln a. This is now in form y equals to mx plus c, right? So which one is my y-axis? So this is my y-axis. Then my x-axis is this one. So I can come here and say this is x, then my y is ln y. Then item 2 says calculate the value of A and the value of B. Okay, so my C is ln A, so ln A equals to my C. My C is the y-intercept, so if I come back here, the y-intercept is this one and it's this one here, 1.1. so this is 1.1, so which means if I apply E both sides, I'm going to get E to the power of ln A equals to E to the power 1.1. This one is same as A equals to E to the power 1.1. So this is my A in exact form, which I can put on my calculator and get around 3. By the way, this E is available on every calculator, so you don't need to worry about its value. You just use it as E because it's available in all calculators. Then now we need to find B. If you look here, this B, ln B, this ln B is the gradient of our graph. So if I say ln B equals to gradient, then ln B equals to my gradient is what? Change in y over change in x. So it's this one, 2.7 minus 1.1. So 2.7 minus 1.1 over my x is what? Is 1 minus 0. So coming back here, I've got 1 minus 0. So this is going to be what? 1.6, like that. So ln B is 1.6. That means my B equals to E to the power 1.6, which is same as 5. So these are my two answers there. So I'm done with this question here. I'm done with it. So let's go to the next one. The next one is from Cambridge, November 2012. So let's read the question. Solve the equation. Let me write the equation. It is 5x minus 1 equals to 5x minus 5. Give me your answer correct to 3 significant figures. So what I can do here is break this one into 5x over 5 to the power of 1, which is same as 5, equals to 5 to the power of x minus 5. So here I used the laws of indices that says if the powers are subtracting like this, it simply means that these ones here are dividing, just like I did there. So now when I'm here, I would say let y be 5 to the power of x to make it easy for me to calculate. So which means I have what? I have got y over 5 equals to y minus 5. If I rearrange this one, I'm going to get my y equals to 25 over 4. Right. Then I'm coming back here. Now coming back here, I've got my y equals to 6.25. This 25 over 4 is same as 6.25. Then, which means my 5 to the power of x equals to 6.25. Then if I apply ln both sides, I'm going to get x ln 5 equals to ln 6.25. Then my x equals to ln 6.25 over ln 5. And on the calculator, it gives me 1.14. This is what? 3 significant figures. So this is the answer there. Then our last one is this one. Show that this one can be written as a quadratic equation in x. So I've got log base 10 x plus 5 equals to 2 minus log base 10 x. I need to write it as a quadratic equation in x. So let's do it. We've got a log base 10 x plus 5 equals to 2. That 2 can be written as a log base 10 of 100. Then a log 10 of x like this. Then these ones are separating, which means I can apply the law of log, which will say log base 10 100 over x. Then this side is it remains as it is, right? Then here, since these are just log both sides like that, I can simply ignore the logs and have x plus 5 equals to 100 over x. Then multiplying everything by x, I'm going to get x squared plus 5x equals to 100. Then x squared plus 5x minus 100 equals to 0. So this one is now a quadratic in x, which is what the question wants there. Then hence find the value x to satisfy the equation. This is just solving the quadratic, so it's irrelevant in this question. We're going to do it later. So this is all about the examples. We can move on to the next topic. Alright, so our next topic focuses on polynomials. So these are algebraic functions of x in which we are concerned about the powers. So first we are going to look at quadratics. So we all recall the general formula of a quadratic from O-level, and this is an example here, and also this is an example there. We also have a quadratic formula here which says minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so in the quadratics we would want to derive the quadratic formula using the method of completing a square. This is a new method, and we are going to take this one and then come up with this using the method. Then after that we are going to apply this method of completing a square on other quadratics. So let us derive the formula. So let's complete the square. We have got a x squared plus bx plus c as a function like that. So what you do, you put your a outside, then here you remain with x squared plus a bx over a plus c over a like this. We just factorized and put our a outside. Then next we maintain our a outside, then we say x plus half of this one, which is b over 2a. Then we don't put that x, we put brackets like this, then we square, then we say minus this one squared, which is what b over 2a squared like this plus a c over a like so. Then we proceed and multiply everything by the a outside. So we're going to have a x plus b over 2a squared minus b squared over 4a plus c. So we are done with completing a square, and then if you do this method on a quadratic, it is going to give you what we call a turning point. All quadratics have something like this, have a graph like this, and we have this point here, which is we call a turning point. So this point we can obtain it directly from this one, which is going to be what? Minus b over 2a c minus b squared over 4a. So these are the coordinates of the turning point. Now that we're done with completing a square, we will proceed and derive the quadratic formula. So what you do is you take our final one here and equate to 0, then make x the substitute formula. So let's do it. We've got a x plus a b over 2a squared minus b squared over 4a plus c equal to 0, right? Now that we have done that, we can move these two to the other side, and we remain with the a x plus b over 2a squared equals to b squared over 4a minus c, right? Then I can simplify this one into b squared minus 4ac over 4a like that. Then I can divide by this a. If I divide by that a, I'm going to remain with the x plus b over 2a squared over 4a squared like that. Then I can then apply the square root both sides. Then it will remove this squared there. So I'll be here now, right? So I can move this one to the other side and remain with the x equals to minus b over 2a plus, before I say plus there, this denominator, this one, I can find its square root, which is going to be 2a. So which makes here plus or minus a square root of b squared minus 4ac over 2a, which I can put under one denominator and have my quadratic formula here like this as 2a. So this is the derivation of the quadratic formula using the method of completing a square. Okay, so the key takeaways from this one is for you to understand that this one represents the turning point. Then now I'm going to do these two examples of completing a square and finding the turning point. So here you put your 2 outside and you have your x squared minus 6x plus 13 over 2. Then next you've got 2 outside, you've got x minus 3 squared minus this 3 squared, which is 9, plus 13 over 2. Then putting my 2 outside, I've got x minus 3 squared. Then simplifying these two by adding them, they are going to give me minus 5 over 2, like this. Then now I multiply with my 2 and I'm going to get 2x minus 3 squared minus 5. So this is my solution, and my turning point is negative 5, like this. So this is my turning point. Then I'm going to do the same thing for this one. I can rearrange this one into negative x squared plus 6x, put my negative 1 outside, like this, and remain with the x squared minus 6x, like this. Then I will have my negative 1 like this, and then x minus 3 squared minus this negative 3 squared, which is 9, like this. Then I'm going to expand with this negative 1 and remain with negative x minus 3 squared plus 9, which can be rearranged into 9 minus x minus 3 squared. My turning point is going to be what? 3, 9. Okay, so this is how you complete a square. Then now the roots of a quadratic equation. This is where the curve cuts the x-axis. So for example, in a situation like this, here we have a curve cutting the x-axis there and there. So these are what we call roots. Then we also have what we call the discriminant of a quadratic. So this is this one here, b squared minus 4ac. So what this one is used, it is used to tell us some information about the roots of a given quadratic equation. So given it like this, if it is equal to 0, it simply means that the roots of that quadratic equation, we only have one root. When you do those calculations, that's where you find the answer, where you say, for example, it's the 1 twice. So that's what we'll be saying. There's only one point where the curve touches the x-axis. Then if this discriminant is now greater than 0, we know that we have two distinct roots. So it is cutting here and here. Then if this one here is less than 0, we have two complex roots, and this implies that it does not touch this line. So we don't have to worry about this complex for now. It is a topic that is coming. So just know that if the discriminant is less than 0, we have two complex roots, right? Then this is all about that. So we can move on to the remainder and factor theory. So these are the two theorems that we use to factorize polynomials that are greater than quadratic in terms of the degree. For example, if you have a cubic or the one with the maximum power of 4, so that's where we usually use these ones. So before we do anything here, I need to mention that we have a factor is something like this, then a root is just a number like this. So having this knowledge, we can proceed to the factor theory, which says if this one is a factor of the function f of x, then f of a is 0. Alright, we are going to do this one in an example, but what it simply says that if you are given maybe x minus 2 as your factor, which means if you go to your function and say f and put 2, we are going to get an equal to 0. Notice that here there's a minus here, but here is plus 2, like here and here. Then moving on to the remainder theory, which says if this one is not a factor of this one, then f of a is going to give us k, which is the remainder when we divide by this one. So these ones I'm going to explain when we are now using them in the examples. Now we are doing the examples. So we are given our f of x as this one, which is the x cubed plus p x squared plus qx minus 81, right? Then our factors is x plus 1 and x minus 3. So which means if I say f of negative 1, I'm going to get 0. So if I substitute my negative 1 there, I'm going to get, after simplifying, I'm going to get p minus q minus 81 equals to 0. So what I'm doing is substituting my negative 1 here, negative 1 here, and negative 1 here. Then simplifying, I get this one. So this one I'm going to call my equation 1. Then I'm going to do the same procedure with this one. So if I put 3, so f of 3 equals to 0. So if I substitute there, I'm going to get, after simplifying, I will get 9p plus 3q minus 54 equals to 0. So this is my equation 2. Then from these two, I can find equation 3 and then solve them simultaneously. So equation 3 is going to be p equals to 82 plus q. So here we rearranged our equation 1. Now we are substituting into equation 2. So it's going to be 9p, which is 82 plus q plus 3q minus 54 equals to 0. Then I'm going to simplify that one and get my q as equal to negative 57, and then if I substitute again, I'm going to get my p as equal to 25. So this is the approach you are supposed to do on this one, right? Now we can attempt another one. All right, now we are done there. So I want to look at polynomial division. So what this is another method. In fact, it is a long division way of dividing this one by its factors. So polynomial division is a long division way of dividing a function like this by its factors. So it's a skill that you're supposed to know. So we are going to do it here using this example that I've prepared here. All right, so let's start dividing there. So what you do is say x, this x outside here, this x into this one here, x to the power 4. That will give us x cubed, right? Then we say x cubed times this x is going to give you x to the 4. Then you say x cubed times this one is going to give you a plus x cubed. Then when you are done multiplying these ones here, you then come and say this and put your subtraction here. Then x to the 4 minus x to the 4 is 0. Then we don't have any x to the cubed on top, so we are simply saying 0 minus this x to the cube, which is going to give us negative x to the cubed, right? Then after doing that, we then say x into negative x to the cubed, which is going to give us negative x squared. Then negative x squared times x is going to give us negative x cubed, right? Then negative x squared times 1 is going to give us negative x squared. Then we subtract again. All right, after subtracting here we get 0. Then here we now have another squared on top, this one here. So we are now subtracting this one and this one. So it's negative 2x squared minus negative. If you say minus negative, it's now plus. So we have negative 2x squared plus x squared, which is going to give us negative x squared. So it's negative x squared here, right? Then x into negative x squared is going to be negative x. Then negative x times negative x squared. Then negative x times 1 is going to be negative x again. All right, now we subtract again. We now have 0 here. Then negative 3x minus negative x is going to give us what? It's going to give us negative 2x. Then we say x into negative 2x, we get negative 2. Then negative 2 times x is going to be negative 2x. Then negative 2 times 1 is going to be negative 2. Then we subtract here. This gives us 0. Then we have this negative 2 here and this negative 2, which will give us 0. So this one is a factor of this one. So if I prove this one using this method that I was showing you on top, the remainder theory and the factor theory, I can say like this. I can say this is my factor x plus 1, like that. Then this is my f of x, which is equal to x to the 4 minus 2x squared minus 3x minus 2, which is this one that we are dividing there. So what I can do is say f to the negative 1, then put my negative 1 here. It's a negative 1 to the 4 minus 2 negative 1 squared minus 3 negative 1 minus 2. So this is supposed to give me 0 because this one is a factor. So I'm going to get 1 minus 2 plus 3 minus 2. So what do I get here? I get 0. So this is what the vector theory is telling us there, that if this one is a factor of this one, then if you put your a here, you're going to get 0. Then the remainder theory tells us that if this is not a factor and you do the same procedure, you are going to get a remainder, or your answer. This answer here, this 0 here, will not be 0. It will be some kind of a number, right? So that's what it's all about there. Then we are going to finish this one by an example, which says the polynomial. Alright, it's not clear. Let me write it down. So we are given the polynomial x to the 4 plus 3x cubed plus ax plus 3 is denoted by p of x. So we have p of x here. We have p of x there. It is given that p of x is divisible by this one, so which means the factor here is x squared minus x plus 1, because we are saying that it is divisible by that one. Then item 1 says find the value of a. Okay, so how do we do that? Here we're supposed to formulate some kind of an equation that we can solve to find the value of a. So what we can do is do our long division, the one that I was demonstrating on top. The reason why we cannot use the remainder theory or the factor theory, in fact the factor theory, is because this one is a quadratic. So if this one is a quadratic, you cannot express it as a x plus a. So we need to find another way, which is the long division. So let's do the long division there. Let me find a fresh page. We have x squared minus x plus 1 as our factor. Then our f of x, or in this case p of x, is x to the 4 plus 3x cubed plus ax plus 3. So I'm dividing now. Right now I'm going to move a bit faster because I've already explained this one. So x squared into this one, I get x squared. Then x squared times x squared, I get x to the 4. X squared times negative x, I get negative x cubed. Then x squared times 1, I get plus x squared. Then I do this and subtract. Alright, then I subtract, these ones give me 0. Then here is a 3x cubed minus negative x cubed, so it's going to be plus there. So I'm going to get 4x cubed, right? Then this x squared doesn't have any x squared on top, so it's just negative x squared, right? Then my x squared into this 4x cubed, I get plus 4x. Then plus 4x times x squared, I get 4x cubed. Then next I get negative 4x squared. Then 4x squared times 1, I get plus 4x. Then I subtract again. subtracting again there, I get 0 here. Then here I get what? 3x squared, right? Then this 4x has that ax on top. This ax minus this 4x is going to give me what? It is going to give me a minus 4 in a bracket like this, then my x outside. Then x squared into 3x squared, I get a plus 3. Then 3 times x squared, I get a 3x squared. Then 3 times negative x, I get a minus 3x. Then 3 times 1, I get a plus 3. Then I subtract, right? Subtracting there, this gives me 0. Then I've got a minus 4 minus negative 3. So this is going to be what? A minus 4 minus negative 3, which is just plus 3. X, then 3 minus 3 there is going to be just 0. And since we're told that this one here is a factor, so I can equate that remainder to 0, because we're supposed to get a remainder of 0. So I can say a minus 4 plus 3 x equals to 0. Then dividing both sides by x, I've got a minus 1 equals to 0. Then my a equals to 1, right? So we have done our item 1. We've done our item 1 of finding a. Now item 2, when a has this value, find the roots of this equation p of x equals to 0, right? So we need to factorize that one and find the roots. Okay, so we're saying that a has this value. All right, so alright, we have this factor here, which is x, the one that I was dividing with, x squared minus x plus 1 is a factor. Then this one on top here, the one that is my result, x squared plus 4x plus 3, x squared plus 4x plus 3. So these are equivalent to p of x. So now what I need to do is solve this one and find the roots. Alright, so I'm going to equate it to 0. So taking the first one, x squared minus x plus 1 equating to 0. Before I waste my time with solving, let me check if it has roots. So I'm going to say b squared minus 4ac. My b is 1, so negative 1 squared minus 4. My a is 1, my c is 1. So is it equal to 0, less than 0, or greater than 0? So this is just 1 minus 4, which is less than 0. So it has complex roots. So this one has no roots. It is those quadratics that you can solve. In this level, we are going to discuss a topic in which they can be solved, but for now we just leave. Then if I take the second one, which is the x squared plus 4x plus 3 equals to 0, and do my b squared minus 4ac, I'm going to say 4 squared minus 4ac, right? So here is 16 minus 12, which is greater than 0, so it has roots. So we need to try and solve it. So it's x squared plus 4x plus 3 equals to 0. So we have to solve this one, and I'm going to do it very quickly because this is not the point of this topic. So this one is x plus 1 and then x plus 3 equals to 0. So my x equals to -1 or -3. So these are the real roots of our quad function. It has a power of 4, which means it is supposed to give us 4 roots, but these roots are complex. So 2 roots that are contained in this one are complex. That's why we're getting only for this one. So this is all about this one. Alright, so our next topic is identities, equations, and inequalities. So here we're supposed to differentiate identity and equation. An identity has 3 dashes like this, while an equation is an equal. Then the identity is always equal. That means the right hand side is always equal to the left hand side for any value of x. But for equations, it's not always like this. So maybe I can try to come up with some kind of example. Let me try an example. An equation, maybe you can say 2x equals to 4. If I substitute 1 in place of x there, it is going to be false. It's going to be 2 equals to 4, which is wrong. But an identity is something maybe like 2x, but it will be a complex functions, not this. But if you substitute 0 or 1 for x, it's always going to be equal. So that's what an identity is, right? Then here is a simple question that we are supposed to look at from November 2007, paper 1. Find the value of a, b, and c such that this polynomial is equal to the product of these two quadratics for all values of x. Okay, so this one behaves like the identity. That means the coefficient of x to the 4 in this side are equal to in that side. So what I can do first is to expand this side. So first I'm going to say this one times this one, which is going to be a x to the 4 plus a bx cubed plus cx squared plus 3ax cubed plus 3bx squared plus 3cx plus ax squared plus bx plus c. Then simplifying there, I've got a x to the 4 plus b plus 3a x cubed plus c plus 3b plus a squared x squared plus then those that have only x, I've got a 3c plus b. So yes, 3c plus b x then plus c. All right, I hope I made correct calculations there. But what you do, you then come here, 2x to the 4 is equivalent to ax to the 4, which implies that our a our a must equal to 4, right? Then next we have this 6 being equivalent to this one here, because they have this x to the 3. So having my a as 4 there, which means here I've got a 12. Then b plus 12 is now equal to 6. So my b is supposed to be negative 6. So b equals to negative 6, right? Then which one has a c? In fact, a c is a constant here, and then here this 5 is a constant, so which means that our c equals to 5. So this is how simple these kind of questions are. All right, so we are moving on. All right, then our next topic is the partial fractions. So this concept involves breaking down combined functions. So we have a function and we want to break it down into a number of simple fractions that were multiplied to get our combined function. So it is necessary to make it possible for us to integrate those fractions. So there are some fractions that are too complex for processes like integration or binomial expansion, so we need to partialize. There are 4 techniques for partializing depending on the nature of the denominator. All right, so we now know what are partial fractions, and we don't really care much about the theory. We care about using the denominator and deciding the method for partializing that fraction. So first we have linear factors. These are fractions whose denominator is a product of linear functions. There's no quadratic here, they're just linear functions. Those functions that have x, they don't have x squared or something like that, just linear. So what we do here, we just come and say a over x minus 1, taking this one, plus b over x plus 2, taking this one, which means if you have another one here, you're going to say plus c over that one. Okay, but we don't, so we end here. So when we are here now, you then say 3. Let me try to clear up here. So now you come and say that numerator, which is 3x minus 2, identical to a takes this one here, x plus 2, plus b taking this one, which is b x minus 1. All right, so this is an identity. This side is always equal to that side. So what we need to do is find the value of a and b. So what you need to do is say let x equal to any number that is going to eliminate either a or b. So we eliminate a by putting our x as -2, which makes this one here 0. If your x is -2, this is 0. That means your a is 0. So you remain with b as the only unknown. So if my x is -2, this side is going to be 3 times -2, which is -6, minus 2. So here is going to be -8, equals to this side is going to be what? -3. So it's -3b. So I can simply say my b is now equal to 8 over 3. All right, then I can come and say my x equals to 1. Now I'm trying to eliminate this one by saying my x is 1, which means if I put 1 here, it's now 0 here, so b is gone. So this side, if I put my 1 here, I'm going to get what? I'm going to get 1 equals to, the other side is going to be 3a. This implies that my a equals to a third. So after that, I come and write my combined fraction, which is 3x minus 2 over x minus 1, x plus 2 identical equal to my a, I said is a 1/3 over x minus 1 plus my b, which is a 8 over 3 over x plus 2. But we don't write it like that. So what we are supposed to do is, if you are dividing like that, it simply means that this 3 will come down here, then this 1 is going to remain there. This is just the division of fractions. Then this 3, then the 8 remains alone on top, like this. So this is our answer. So imagine if our b had a negative here. If it was negative like this negative was going to come here. All right, so you need to take note of that. Okay, so we're done with the first one. It's called the linear. So this linear means that the denominator is these linear factors. So let's go to number 2, which is the quadratic factor. So the quadratic factor, yes, in the denominator it has some kind of quadratic here, like here it has some quadratic here. But a confusion that usually comes if they do this and say maybe in your denominator they put it 2. Let me use a different color. If in your denominator they come and say 2 minus x, then this side they say x squared minus 1. Someone might say this is a quadratic, but it's not, because this one is like this. This one can be simplified into x minus x plus 1 and x minus 1, because this is difference of 2 squares. So you should not fall for that. You need to make sure that the quadratic part is not factorizable. This one, you can't factorize this one further. So that's why we are saying it is the quadratic. Okay, so for the quadratic, you come and say a over 2 minus x plus b x plus c over 1 plus 2x squared. We just did the same thing like we did on top, and then we are going to continue doing the same thing by saying the numerator, which is 2 plus 5x plus 15x squared identical to a, then we cross multiply the 1 plus 2x squared plus bx plus c 2 minus x, like this. We're still doing the same thing as what we did on top. The only difference is that here we are not putting b, we're putting bx plus c. Okay, so this is the only difference there. Now let's solve this one. First, we need to eliminate these ones. So let's do that. We're going to say x equals to 2. If our x is 2, it means this one here is going to be 0, so everything here is 0. We remain with a. So that means this side, if I put 2 here, I'm going to get 7, 2 equals to the other side. I'm going to get 9a. This implies that my a equals to 8. Okay, then if I say now the aim is to eliminate either b or c, because a I already know. So if I eliminate my b by saying x equals to 0, so I'm going to say x equals to 0. This is going to eliminate bx there, so I'm going to remain with what? 2, this side equals to the other side is a plus 2c. I already know my a, so it implies that my c equals to what? So if I put my 8 in place of a there and rearrange, I'm going to get my c as equal to -3. Okay, now I can put any number for x because I already know a and c, so I can find b very easy. So I'm just going to say when x equals to 1, then I'm going to get 22 equals to 3a plus b plus c, making my b equivalent to 1. Then when I'm done, I'm writing the original one, which is 2 plus 5x plus 15x squared over 2 minus x, 1 plus 2x squared, identical to my a is what? 8 over 2 minus x, plus my b is what? 1. So for bx, I'm just going to put x, then plus c, which is -3, then over 1 plus 2x squared. So this is the answer. We have partialized. So there's actually a way of proving all partial fraction questions, including the one on top. I just forgot it on top, but here what you do, if you want to confirm that this is correct, you choose any number and put that number in place of x, all x's. This side, whatever you get on the left hand side is going to be equal to the right hand side for any value of x. Alright, so in the third type, we are dealing with the repeated factor, and in this type you are given a denominator that contains a linear. This inside here is a linear being squared. We are calling it repeated. So this repeated can be repeating any type. Maybe we can also have a 1 plus 2x squared, then we repeat it. This repeating means that we are squaring everything, or we are simply squaring a certain type. This one is a linear, we can square it. If you square it, it's now a repeated. This one is also a linear, so this squaring here means that it is a repeated. Even if you have x squared like this, this is now a repeated because x is linear. So if you square him, it's now a repeated. So a repeated has this kind of approach here. First, we have this denominator here, which is a over x minus 2, then plus we now go to b over x plus 1. Since we're dealing with the repeated, we do it again here by saying plus c over x plus 1 squared. Notice that here we are putting a squared, here we are not. So this component here is a way of dealing with the repeated like this. Okay, so we can now continue to solve. So in the last one, you noticed that we are saying 4x squared minus 3x minus 1 equals to a. So which means our a is going to take our x plus 1 and then our x plus 1 squared plus b, taking x minus 2 and then x plus 1 squared like this plus c, taking x minus 2 and then taking x plus 1 like this. This makes sense because that's what we're doing. We're kind of cross multiplying, but in this case we don't do it like this. So what you do is this. You do it like this. You come and take your denominators there as a x minus 2 and then x plus 1 squared. These are your common denominator. Then for the first one, you say this one into here is going to cancel here, so you're going to remain with a and then x plus 1 squared. That's how you come up with this one for a. Then b, you put your b here, then this one is going to cancel here, so you're going to remain with the x minus 2 and x plus 1. Then for c, we are doing the same thing, plus c. Then for c, this one here will cancel here, so you're going to remain with the x minus 2. So this one is not supposed to be visible here, so you're going to do it on the side. So here is a plus c x minus 2 like that. Then if I say x equals to negative 1, this side I'm going to get 6 equals to, the other side I'm going to get negative 3c. This is going to make my c equals to negative 2. Then I can come again and say x equals to 2. I'm going to get what? My 9 equals to 9a, which is going to make my a equals to 1. Then now I can say when my x equals to 0, I'm going to get negative 1 equals to 1 minus 2b plus 4. Since I already know others, I have my b equal to 3. Then I can rewrite this one as 4x squared minus 3x minus 1 over x minus 2 x plus 1 squared, identical to 1 over x minus 2 plus 3 over x plus 1 minus 2 over x plus 1 squared. So this is how you are supposed to do that repeated type. Okay, then now we are moving on to number 4, which is the improper fraction. So what does this improper mean? It means that we have a quadratic here, we have a cubic here. The cubic is a higher degree, this one is smaller, so it is referred to as an improper fraction. Okay, but in this case it also affects the ones where we have quadratic on top and quadratic at the bottom. For example, if we have something like 2x squared plus 5x minus 4 over x minus 1 squared, this one is an improper, because if you expand the numerator, it's going to be quadratic, and on top we also have a quadratic, so that's why we say it's an improper. So this quadratic type, you start by doing a polynomial division. So let's do it. So we have what? X squared plus x minus 2 dividing our x cubed minus 2x squared minus 4x minus 4. Then x squared into x cubed, we got x, multiplying there I've got the x cubed plus x squared minus 2x, subtracting there I've got minus 3x squared minus 2x, then I've got minus 3 here, minus 3x squared minus 3x plus 6. Okay, then subtracting there I've got x minus 10 as my remainder. So it simply means that I've got my answer here and my remainder there. Then now we need to factorize our denominator, which is x squared plus x minus 2. So I'm going to do that quickly. It's going to give me x plus 2 and then x minus 1. Okay, so I have this one like this. Now I can come here and say my x cubed minus 2x squared minus 4x minus 4 over x plus 2 x minus 1. I factorized this one, equals to or identical to x minus 3. This is what we've got here on top, plus our remainder, which is a x minus 10 over x plus 2 x minus 1. So this is how you approach the improper one. When we have done this, you now do the partial on this one. So the partial of this one we already did it. This type we already know it is the linear. So let's do the partial of this one. So we have x minus 10 over x plus 2 x minus 1 identical to a over x plus 2 plus b over x minus 1. So we've got x minus 10 equals to a x minus 1 plus b x plus 2, like this. Then if I say x equals to 1, I'm going to get my b equals to negative 3, and then x equals to negative 2. I'm going to get my a as equals to 4. So what I did here we already know. This is just simple partial fraction for the linear type. Then now we can write our final answer. Final answer is what? It is a x cubed minus 2x squared minus 4x minus 4 all over x squared plus x minus 2 equals to or identical to our x minus 3 plus, then here we now put our a, which is 4 over x plus 2. Then for the b is negative, so we put negative here, and then we say 3 over x minus 1. So this is how you approach the improper type. So we are done with the partial fractions. Now our next is going to be inequalities. Alright, so today we are looking at inequalities. So before we proceed, we need to look at a few rules. So the first rule is that there is a sign change when you are dividing with a negative. So if you have something maybe like a 2x is greater than 4, something like this. Alright, let me say if you have negative 2x is greater than 4, when you are dividing with negative 2 there, so negative 2, you're supposed to change your sign like this and have x is less than our negative 2 here. So this is what we mean. Then another thing is a definition of the critical value. So the critical value, when we are talking about the inequalities, is the solution that you get if you remove this sign here. If I remove here and put an equal here, I'm going to get the value for x. That value for x is what we call the critical value. So in this case, if I have my x minus 4 is equal to 3 minus x, if I move my x to the side, I'm going to get 2x equals to, taking my 4 to the side, I'm going to have 7. So my x equals to 7 over 2. So this is my critical value. In this case, it's useless, but in the next steps, we are going to see why it was important for us to talk about it. So for inequalities, we have many types. This one is the basic one, which is the linear type. So we've got our x going there, and we're going to have a 2x is less than our 7. So x is less than 7 over 2. So this is the answer here. No problem there. So this is the simplest of our inequalities. Then moving on, we meet the quadratic type of inequality. So a quadratic is something that is in that form, which is ax squared plus bx plus c. In this case, this is not that form, but if we try to expand it into x squared plus x less than 12, then moving 12, we're going to get x squared plus x minus 12, which is less than 0. So it's now a quadratic. So a quadratic type, you find the critical values first. So what you do is say x squared plus x minus 12 equals to 0, then find the solution to that. So I'm not going to do quadratic solving here. I'm just going to go straight and say this is same as x plus 4 x minus 3 equals to 0. So my x equals to minus 4 or 3. So if you have done this for quadratic, you then come and sketch it like this. Then you put your negative 4 here and 3. So these are your critical values that you put. Then once you have put your critical values, you then come here now to your sign. The sign is less than 0. So something that is less than 0 is below the x-axis. So which means the region is this one here. So we're looking at the region where our curve is below this line. and this region is this one, which is from -4 to positive 3. So our answer now becomes -4 less than x less than 3. So this is the solution there for the quadratic types. So that is how simple it is. So let's recap. You first find your critical values, then you sketch. You need to be able to sketch a quadratic graph. This one is not a secret. You need to know that. You need to sketch. If you try to use other techniques, you might get lost. I'm going to show you another technique that might work for this one, but for now I recommend this one. I think this one is simpler. So another type of inequality is this one that we call the rational. Why are we calling it the rational? The rational is a type in which x is part of the denominator. Okay, so x is part of the denominator. So if you look at this one first, you can simply say I can multiply by x and eliminate that x as a denominator. But for inequalities, it does not work like that. That is why we are saying it is the rational, which is a special type, because if I multiply by x here, I'm going to get a quadratic, but we are not doing that because we said the rational is the one that has a denominator which is x, and if your x is the denominator, it means there's a special treatment that you do. You don't do like the quadratic. So the reason why we don't multiply by this x is because specifically for inequalities, we don't know the sign of this x. So if you don't know the sign of this x, you can't multiply by x. So that is why there's a special treatment that we do to this type of question. So this is what I'm going to show here. So what you do is you move everything to one side. So you've got a 3x plus 5 minus 2 over x is greater than 0. Then now you have your x as the common denominator. You have x. Then we have 3x squared plus 5x minus 2, like this, is greater than 0. Alright. Then now you have the quadratic on top and that x as your denominator. So what you do is you solve that quadratic on top there. So I'm going to also fast forward it and have it as a 3x minus 1 x plus 2, and then put my x there and say greater than 0. So now when I'm here, I can find my critical values. So let me find my critical values. I'm going to come here and say, I'm going to divide here and say my 3x minus 1 equals to 0, or my x plus 2 equals to 0, or my x equals to 0. So which means my critical value for x equals to I've got 0, I've got -2, and I've got 130. So these are my critical values. Here you need to know your sign first, then you can rewrite. Your next step could be this thing but with an equal here, but here I don't have a space. That's why I just moved from here to finding critical values. So when you have found your critical values, you see that we have 3 critical values, and for this type, the rational, you don't sketch. There is an easier method. So this easier method is this. You come here and take this one, you put here, this one you put here, and then this x you put here. when you put them, you then take your lowest critical value here, which is this one with a negative, and say when x is less than. So here I made an error here, it's supposed to be less here, it's supposed to be less there. So you say when x is less than the lowest, then next you say when your x is between the lowest and 0, then you say when it's between 0 and a third, then you say when x is greater than a third. So we are simply covering everything, because we have -2 here, we have 0, and we have a third here. We are arranging them in their size. So you need to cover this space here, which is this one, then you need to cover the space, which is this one, then you need to cover the space, which is this one, then you need to cover the space, which is this one. So you are here now. You then come and say when your x is in this range less than -2, what are you going to get here? You are saying your x, when your x is in this range, then you substitute your x here. Are you getting a plus here or what? So that's what we are doing. So if I put my -3 here, I'm going to get what? A negative here. Okay, then next, if I put my -3 here, I'm going to get a negative, then also here I'm going to get a negative. This is what we are simply doing here, and you're going to do it here. Here you're going to use -1 here, we use -1, so put -1 here, you're going to get what? A negative there, going to get a negative there, a plus and a minus, and so on. Going to get a negative, going to get a plus, you're going to get a plus, then you're going to get a plus, and a plus. Once we have done this, now you now come to this one. You're supposed to multiply these ones. So minus times minus, it gives you a plus, then plus times this minus gives you a minus. So here it's going to be a minus, then here is what? Minus times a minus, which is a plus, then plus times this plus is going to be what? A plus here. Then here it's a plus times a plus, which is a plus, then plus times a minus, it's going to be a minus. So here is a minus, then here plus it times plus is plus, then times plus is, so here is plus, right? So now since we have this sign here which is greater than 0, we want those that are positive, and those that are positive are this one and this one, which means our answer is this one and this one. You need to rewatch this one so that you really understand. So it's -2 less than, like this. So this is the answer there. This is how you approach this. I hope you understood, but if you don't understand it correctly, you can rewatch it. Let me try to recap it. So I said this one is a rational type because the denominator is x. That means we cannot multiply both sides by x. So we do this method, and then we get to this point here. Then when you get here, you find your critical values. When you have your critical values, you come here with your critical values, your lowest one here, and arrange them like so. Then after that, you take these guys here, then you put them here. Then now you take, this is a range, right? These are ranges. For example, this is a range. We're saying when x is greater than a third, which means something that is greater than a third, I can take 1 or 2 and then put him here. If I put him here, I'm going to get a value here, and that value is going to be positive. That's why I put positive here. So that's what you do for all these ones here. Then after that, you now multiply them to get these ones. Then depending on whether you have greater than or less than, if this one is greater than, if this sign here is greater than, you then take the positive. If it is less than, you take the negatives, and you're going to be having these ones as your answer. I hope it is understood. Okay, so we are done with the normal inequalities. We are going to meet other inequalities that are called modulus inequalities later, but for now we need to talk about what exactly are modulus functions. Alright, so next we are now looking at what we call modulus functions. So these functions have this sign here, these two dashes here. So these dashes, they imply that you want the absolute value of x. For example, we can have something like -2 like this. If you have this, your answer is going to be 2. These ones give you the absolute value of everything that is inside here. By absolute value, we are saying that we are ignoring this sign here. So if we have a function like this, we know that every function can be represented on a graph, and this one here means that our graph, the one that we know of y equals to x, which is this one here, which is just a straight line like this, is no longer like that. It's now a straight line like this, but when you get here, you now go up like this. Okay, so that's what the modulus functions are. So let us do a little bit of something here about these modulus functions. If we are given y equals to x like this, and you can be given that 10 equals to x like this, so it means that my x is now equal to what? To either -10 or 10. This is what this graph is saying here. It's saying that for y here, which is 10, my y is 10 there, I now have two possible values of x, which is positive 10 and negative 10. This is what this means. Okay, so knowing that one, it also follows that if we have something like our modulus like this, it also follows that my x is greater than -10, or my x is less than 10 like this, which in simple terms means that we have x here, -10, and then our 10 there. So this is where we wanted to get. This is what I wanted to show, where we are getting it. So the key takeaway from this situation is that if you are given something like this of a constant, maybe we can say is what? It's a k. It implies that our x is like this. Here you have -k and here you have k. This is what I wanted to derive, or this is what I wanted to show where it is coming from, because everything that we are doing here, starting on modulus functions, was to show you where this general rule is coming from. So this is now a general rule that you are supposed to know, and we can start on our modulus inequalities. So these type of inequalities also have the most basic one, like this one here. So using this rule, I can have my -5 here, and then put this one here, which is the x minus 3, then my 5 there. We have this situation here, then we are simply converting it into this form. Alright, when you have done that, you then separate. You now have, let me change the color to red. You now have your negative 5 less than x minus 3, which you can solve and get your answer as minus 2 less than x. So this is our first answer. Then another answer, you've got x minus 3 less than 5, and then we've got x less than 8, like this. These are two answers there. And then after you have done that, you need to look at this one now. Look at here. Here they are saying that our x is greater than negative 2, but here they say that our x is less than 8, so which means our x lies between this one and this one. So you need to reconvert this one into, you need to leave your answer as this one, negative 2. This is how you leave your answer. So you'll be done if you have your answer like that. Now we have another type here where you have two moduluses like this. So this type, if you have modulus this side and modulus this side, and all x's being inside the modulus sign, the way you approach this one is to square everything. We just square both sides, because the problem here is that our modulus, we don't know the sign of what is in the modulus, because we say it here that it can be positive or negative, so we don't know the sign of what is in the modulus. But if we square, it's just going to be a positive, because if you square negative or if you square positive, it's just going to be positive. That is where the idea of squaring everything comes from. So here we just square, take that 3 and have it 3 squared, which is 9. Then x plus 1 squared less than x plus 2 squared, like this. Then if I square there, I'm going to get what? This side I'm going to get 9x squared plus 18x plus 9 less than x squared plus 4x plus 4. Then I can simplify that one into 8x squared plus 14x plus 5 is less than 0. So I'm here now. If I'm here, I'm now having a quadratic type, and a quadratic type, I did it here. This is a quadratic type, this one here. This is a quadratic type, and you solve it using this method. So that is what you now do to this one. Alright, then we have the third type. The third type is having a modulus on one side like this, and the other side has x but no modulus. On top here we have had moduluses, but now we have a function that doesn't have a modulus, and that's where things get a little bit complicated. So that is why we're supposed to use a different method. So this method makes things easier for us. So what you simply do is you sketch these two graphs. If you're good with the sketching of graphs, you are good. Besides, sketching of lines is very simple. You just find 2 points. So taking this one here, you just do it like this. Like this. You have your x here, you have your y. You have your, when your x is 0, your y is what? If I put 0 here, I'm going to get my y as what? Because the graph we are trying to sketch here is graph of y equals to x minus 6. If my x is 0, my y is negative 6. I'm going to tell you why we're not putting the modulus when we are sketching here. Then we say when our y is 0, our x is what? We find that our x is 6. Okay, what we're trying to do here is to sketch this graph, but like here I sketched this one and this one. So to sketch this one from this one is pretty straightforward. Trying to sketch this one straight is different. So what you do is just sketch this one, but when you get here, you just do it like this, then put the reflection here. This one is your mirror, just put your reflection there, something like that. So that's why we are sketching this one without a modulus. So that's why here we drew this one here, which is this one. Then to get this one now, you simply reflect it here. So this is here, we have drawn it. Then we also sketch this one. This one is just straightforward. Got your y equals to 3 minus 2x there. Then you create your table like this. You've got your x, you've got your y. When x is 0, my y is what? My y is 3. If my y is 0, my x is 3 over 2. Okay, so to sketch a straight line, you simply need 2 points. So you then find those points, then just join them with a ruler. So that is what was done here. Okay, so when you have sketched these 2 lines, now you just need to find where they meet. So they meet here. So this is what we refer to as our critical value. So now having our critical value, we need to come back here. Coming back here, we are now saying this one is less than this one. Let's go on the graph. We're saying this graph here is less than this one. So this is our graph here. It is on top of this one. I hope you can see this one is on top from here to there. It is on top of this one, but after our critical value is now below this one. This one is now below this one here. Okay, so this is what we want. So we want the region from here, from our critical value, going back where this one is greater or where this one is below. Okay, so that is where we come and say our x is less than our critical value there, which was what? Which is this one here. But what is our critical value? We need to find it. So to find it, we simply do the calculation. Alright, so now we are coming back to this one here, this one here. So let's come here. We are taking our x minus 6 at the center there. Then we put our 3 minus 2x here. Then this side we are putting it as negative 3 minus 2x. Then expanding there, I've got minus 3 plus 2x less than x minus 6 less than 3 minus 2x. Then I separate, I get minus 3 plus 2x less than x minus 6. and the side I get x minus 6 less than 3 minus 2x. Then this side I've got what? I've got this x coming this side, and I've got x less than, then that 3 going there. I've got what? Negative 3. Then this side I've got my 3x, this side less than 6 going there. I've got 9, so it's x less than 3. Okay, so I've got this one and this one, but according to our diagram here, our critical value is only -3 here. So that was the main point for drawing this graph, so that we can see that our critical point is here. So our answer is now this one only. Then now the next topic is functions and relations. So basically on functions, you just need to know the definition of a function, which is referred to as a one-to-one mapping, which means one value of x is supposed to give you one value of y. That's simply what a function is. Then one of the most important thing here is the ability to sketch a number of different functions. For example, with the linear, the quadratics and stuff, you need to be able to sketch those ones. Or at least if you are seeing a diagram, you need to tell whether this is linear or quadratic or whatever. That is why I was emphasizing on that. So I'm going to show you the types that you're supposed to be able to sketch. So let's do it. The linear, a linear is a straight line. So you can have it as here, this is y equals to x. Then you can have also have it here or here or whatever, as long as it is a straight line. It's a linear. Then quadratic, we know that is something that is supposed to be like this. It can be here, or it can be here, or it even can be on top like this without touching your x-axis. Another quadratic can also be something like this, the inverted one. So you need to be able to draw the quadratic. Then we have the cubic. The cubic is something like this. Then we have the exponential. The exponential example is y equals to e to the power x. This e, you need to remember that it is a number. It can also be y equals to 5 to the power of x. This is still an exponential. So an exponential is like this, something like this. It gets closer to our x-axis here, but it doesn't touch. Then we have what we refer to as a logarithmic. So this can be y equals to ln x, or y equals to log x. This one is like this. It's not touching the y-axis, and it does this. Then we can also have the trigonometrical. This one can be y equals to sine x. So the sine x is going to be like this, or y equals to cos x, or y equals to tan x. You're supposed to know this graph. When you see it, you need to know what that is a trigonometric or what. You need to know those things. Then your syllabus also wants us to recognize the decay and growth curve, but these are very simple. The decay, you are saying that we are starting with a high value for y, which it decreases as we go, as time goes. So a decay is something like this. Then a growth, something like this. Okay, Then after that, you need to understand a few words. So you need to understand this word, which is referred to as domain and range. So the domain is the x value and the range is the y value. This range is also referred to as the codomain. Okay, like here, the range is referred to as the codomain. Sometimes when you're given a function like this, they also give you this something like this. If you have seen a function correctly, they also give you something like this. This is what we refer to as the domain. So the domain can be used to make an expression into a function, because we said a function is a one-to-one mapping. That means if you have your graph like this, I want this value of x to equivalent to one value of y. But for quadratics now, we can have a situation like this, where this value of y is equivalent to this x and this x, like this x and this x equivalent to this one. So we don't want that. So that's why we can make a domain that this is a function, but it starts from here to here. I hope you understand what I mean, because if you just say your function is quadratic, but you don't tell us that your function is defined from where to where, it might not be a one-to-one mapping, which is not a function. So you might find a question that says you are given a function which is a quadratic, and they will ask you to make it a function by giving the domain. So you need to make sure that your domain makes it one-to-one mapping. So for this type of scenario, if you are following my past exam papers, you will see a situation where the question was looking for that. Another thing that you should just put in the head is that the range of a function is the domain of its inverse, and the domain of an inverse is the range of the function. For now, you don't know what an inverse is, but after knowing what an inverse is, you are going to understand what I mean. So now we can move on to the inverse of a function, which is denoted by this. It's just a function f of x with this minus here to the power of minus 1, like that. So graphically, the reflection on the line y equals to x is what we refer to as an inverse. Like here, this is line y equals to x. I've been showing this graph a lot. By now, I'm pretty sure you are now able to draw it. Y equals to x. This is the line here at the center there, and we have this one here. This is its reflection. So it means that this one is a function and this one is an inverse. I hope you understand. So y equals to ln x is the inverse of this one here. Graphically, the inverse is the reflection on this line. That's what you're supposed to take home there. Then we're now moving into the inverse of a function by calculation. So finding the inverse of a function by calculation is simple. All you have to do is make your x the subject of the formula. After doing that, you then exchange. Where there is x, you put y. Where there is y, you put x. You'll be done if you do that. But we are going to do this one. We are going to do the example for this one. So before we proceed, let's just take a quick look at what we call a composite function. These are combined functions. For example, we're given like this, our f of x here and our g of x like this. Then they say find fg of x. So the way you approach this one, you write your f. So fg of x like this equals to, if I want to find fg of x, I write my f, which is a 3 ln 3 x minus 2 like this. But I need to replace every x in this one by the whole of g. So what I do is remove this and replace the x with g. So it's going to be x plus 1 like that, then minus 2. Then I simply simplify this one. So 3 ln, in the bracket there I've got a 3x plus 3 minus 2, which is going to be equal to 3 ln 3x plus 1. This is your answer there. So if you are looking for g f x, you simply write your g, but in place of this x you put f, and then you simplify. That's simply what a composite function is. Alright, so before we move on to the examples, we need to also look at the transformations of these graphs. So the transformations are used to help you sketch graphs. For example, if I'm given let me say y equals to x squared, and I'm trying to sketch maybe y equals to x squared plus 2. I now know that this one is just this first one here translated by 2. So that's what we want to teach you. So let us do first with the translation in the y-axis. So translation, we know that we're just moving the whole thing to a new location. So like here, let me zoom in here. Here we are given this y equals to x squared, which is the one that passed by 0, the black one. Then we just put it up by 2. We just translated it up by 2. Here we translated it down by 2 units. That's what it means here. If you are adding your a to f of x, we are just saying a units up. If you are separating your a from f of x, you are simply saying a units downwards. That's just translation in the y-axis. Now in the x-axis, now we are moving in the x-axis, which means it's left or right. So if you are adding your a to x, you are moving to the left. If you are separating your a from x, you are moving to the right. If you are adding your a to x, you are moving to the left. If you are separating your a, you are moving to the right, just like here. Here, this is your graph here. You moved it that side because you are adding, then you move it that side because you are separating. That's just the simple translation there. Then after translation, before we do that, let me demonstrate what we mean by this one adding to x. If I've got y equals to x squared, I can translate it by saying y equals to x plus 2 squared. This is translation to the left by 2 units. Then we have got the stretch. So the stretch, you can stretch up and down, or you can push like this, squeezing. Okay, so in the y-axis, if you have your scalar multiplying your f of x, you are simply pulling. Then if it is dividing, you are squeezing. So let me demonstrate here. You can have your y equals to x squared and your y equals to maybe 2x squared. This 2 is stretching this thing up and down. But if you have y equals to x squared over 2, we are squeezing it up and down. Okay, then on the x-axis, the story is like this. If you have y equals to x squared and y equals to ax all squared like this, we are squeezing. But if it says y equals to x over a all squared, we are stretching. Then for reflection, if you put negative on f of x like this, it's a reflection on the x-axis. For example, if you have y equals to x squared as your function, and then you say y equals to negative x squared, it's a reflection on the x-axis, right? Because I'm pretty sure you know that this one is like this, then the one on top is like this. So it's a reflection on the x-axis like this. Then if we have y equals to negative x, then square like this, is a reflection on the y-axis. But in this case, it won't work here, because if you want to reflect on the y-axis, this side and this side are the same, so you won't see if reflection has occurred or not. Now we're looking at past exam questions, and our first one says a function is defined by f of x equals to x squared plus 4x plus 1 for x is greater than or equal to negative 2. Find the range of the function. So to find the range, you use the method of completing a square. We actually talked about this one when we were talking about the method of completing a square back in our first topics there. So I'm going to repeat it here. So let us find the range. By the way, we said the range is the range of values of y for which our function is valid or is defined. So let's complete a square here. We have got our f of x equaling x squared plus 4x plus 1. So to complete a square, I will come here and say my y equals to x squared plus 4x plus 1. So which means I've got x plus half of 4, which is 2. Then I square, then I subtract that 2 squared, which is 4. So it's minus 4 plus 1. I've completed a square there, which is x plus 2 squared minus 3. So I'm done there, which means if I've done that, it means my range, you then write it like this: y is greater than or equal to negative 3. So you just pick your range from here, just take this one as it is here and just put it here. Make sure that you use the greater than or equal. And now I'm going to explain why we do that. So we have our graph here, which we know that right before we go there, from this method of completing a square here, we get what we call our turning point. So this turning point is what is -2 and -3. I'm getting it from here and here. We actually did this when we're talking about the completing of square. So which is -3 here and -2 here. So it's here. So you've got a function like this, and in our domain here we are told that x is greater than or equal to -2. So it's here. They are saying that our x is this one going there. So you remember what I was talking about, saying that the domain is designed to make sure that our function is 1-to-1. From here going there, that's where our function is 1-to-1, because this value here is equivalent to this value. We are not going here and here because we end here. That's what our function is defined for. All right. So the range now, when our domain is from here going there, the range is from here going up. It goes way up. We don't know where it's end. That's why we're simply saying that our y is greater than or equal to -3. Our y starts from -3 going up. That's what this range is. All right, then moving on to item 2. This was item 1. Item 2 says find the expression for this one stating its domain. So this one we said is the inverse. So let's find the inverse of a quadratic. And to find an inverse, we actually said the statement for finding an inverse. We said for, in terms of graphs, it's just a reflection on the line y equals to x. But by calculation, we make our x the subject of formula. Then after that, we simply exchange x and y. Okay, so let's do that. So the inverse here, the inverse, I'm going to take this guy here, this one here, because it's y equals to this. I'm going to take it from here and make my x the subject of the formula. So y equals to x plus 2 squared minus 3. Then making x the subject of formula, I've got y plus 3 equals to x plus 2 squared. Removing that squared, I'm going to say y plus 3 under a square root equals to x plus 2. Then moving 2 to the side, I'm going to have -2 plus or minus square root of y plus 3 equals to x. So I'm now exchanging. I'm now having y equals to -2 plus or minus square root of x plus 3. So this is now my inverse, and I can remove this y here and replace it by my f to the power -1 of x. So this is the inverse. And then when we are doing our inverse, our question says state its domain. And I also said that the This is the statement that I was referring to here. I said the range of a function is the domain of its inverse. So what I'm looking for now is the domain of my inverse. So the domain of my inverse here is the range of my function. So coming back, my range is this one. So it is now the domain of my inverse. So to write my domain, I'm writing it as x is greater than or equal to -3. Notice that here we are using x, we are not putting y. So this is all about this number 1 here. Now we can try our number 2. And number 2 says the functions f and g are defined by f of x equals to e to the power of 2x for x is an element of all real numbers. Then g of x is equals to square root of x for x is greater than 0. Then item 1 says find g of x. Okay, so g of x, let's do item 1. Item 1, we want g of x. So this one is simple. I simply said you take your g, which is this one, square root of x, and you put your square root like that, and then in place of x you put your f. So this is e to the power of 2x. So this is our answer there. Then moving on to item 2, we want to find the inverse of f. So inverse of f, I want to find it here. How do I do that? I take my f, which is e to the power 2x, and say y equals to e to the power of 2x. Then I make my x the substitutive formula. So to make x the substitutive formula there, I apply ln both sides. So I'm going to get ln y equals to 2x. Then I divide by 2 and get my x equals to ln y over 2. Then y equals to ln x over 2. That means my inverse is now ln x over 2. Okay, then now we are moving on to item 3, which says we want f of inverse of g. So first what you can do is find the inverse of g. What is the inverse of g? My g is what? Is the root of x. Okay, so making f the subject there, I can have my y squared equals to x. Now my x is the subject, then I can have my y equals to x squared when I'm exchanging x and y. Now that I have this one, I can call gx to the power -1. So when I'm looking for f g -1 of x like this, it simply means I'm taking my f, which is what? Which is this one here, e to the power 2x. So is e to the power 2. In place of x, I'm now putting this one here, which is x squared. So x squared there. So this is my answer there. So here is supposed to be x squared there. And then now we are on coordinate geometry. This is a very short one. but it is very important, and there are formulas that need to be noted down. So let us look into it. So first, we are looking at the straight line, and the straight line is a line just like a quadratic curve, so it has its own equation. So the general equation for the line is this one, which says y equals to mx plus c. For quadratic equation, we know that the general equation is just a x squared plus bx plus c. So for a straight line, this is our general equation, and this general equation means something. So this is y equals to mx plus c. This c, it is the point where our line meets the y-axis. This m, it is the gradient of that line. So in my illustration here, this is my c, where my line meets the y-axis. Okay, so another thing that we need to know here is how to calculate the gradient of a line. So to calculate the gradient of a line, you need 2 points, either here or here, or just 2 points. So I chose here and here. So my points are labeled like this. I've got x1, y1, and then x2, y2. So to find my gradient, I'm going to use this formula here, which says m equals to y1 minus y2 over x1 minus x2. You can interchange this one. You can say y2 minus y1 over x2 minus x1. It doesn't matter. Your answer is going to be the same. Notice that we usually refer to gradient as m. That's why I'm using m here. Then we need to know the properties of gradients of lines. So if I have 2 parallel lines, it means that their gradients are equal. 2 parallel lines have the same gradient. But if those lines are perpendicular, meaning that they meet at 90 degrees, their gradient is not equal. The product of their gradient gives me -1. Just like here, the product of gradient 1 and gradient 2 is -1 if those lines are perpendicular. So these lines are usually referred to as the tangent and the normal. A tangent will be like this, then the normal will be like this. They'll be meeting at 90 degrees, and the product of the gradients of tangent and normal is -1. So these are 2 properties that you need to really understand, because you're going to use them a lot. Then there's also a formula for finding the midpoint. For example, if I'm given this point and this point, I need to find the midpoint around here, the midpoint, which is another point. So if I want to find this point here at the center, I do it like this. So midpoint equals to x1 plus x2 over 2, comma, y1 plus y2 over 2. Then another thing you need to be able to find is the distance between 2 points. So now we're now talking about the distance, this distance from here to here, this distance here. We've got x1 minus x2 all squared, y1 minus y2 all squared, then all under a square root, and you add it. Okay, then another property, if we have to solve, let me just say it without reading. If we have 2 equations of either lines or curves, or a line and a curve, if you solve those equations, as simultaneous equations, just like we were doing back in O-level, where you just solve this simultaneous equation and find the answer for x and y. Whatever you find is the point of intersection of those lines. So if I have my line here, it has an equation, and then my line here, it has an equation. If I take those equations and solve them as simultaneous equation, I'm going to find this as my answer. The answer that I find is this point. It's a point that is common to both those equations. Then we move on to this circle. So the circle is also, it has a line, so it must also have an equation. Okay, so how do you find the equation of a circle? If you're given the center, the point for the center and the radius, you can find your equation like this. You have x minus a squared, then y minus b squared equals to our radius squared. So if you simplify this, you are going to get your equation in this form, in a form like this. Okay, but generally we just leave it like this. But you can also be given this expanded form and be required to find the center and the radius. So to find the center, you do it like this. The coefficients of x here have this g here, and the coefficient of y is this f. These ones are the ones that we are using here to find our center. Notice the negatives here. Then for the radius, we also use this g and f. Then our c here. Here, something that might be a problem here are the signs. So you need to take care of this sign here, there are signs here. So you need to notice these signs when you are calculating g and f. Otherwise, if you make a mistake there, you're going to not get your answer is correct. But we are going to do an example on this one. Then you also have something referred to as parametric equations. So an equation of a circle or a curve or a cone can be represented by two equations like this, where we have our x being something and our y being something. Of course, I can move from this one to the equation of a circle using this identity. It is called the trig identity. We are going to learn about it when you are now doing trigonometry, but for now it's something that you should know. So the way you get the equation of a circle is this. You simply square everything there and get x squared equals to a squared cos squared theta. Then you square your y and you get y squared equals to a squared sine squared theta. Then you just add x squared plus y squared equals to a squared cos squared theta plus a squared sine squared theta. Here I can factor out my a squared and get cos squared theta plus sine squared theta. Then this side x squared plus y squared. So this part now is equivalent to this one. So my result is going to be x squared plus y squared equals to a squared. So this is another general equation for the circle, but this circle has its center as 0, 0, or the center of this circle is the origin. So this parametric equation, you just need to know that there's something called parametric equation, but you're not going to do something much with them. You might meet them in other topics, but you should know what they mean. Then we're moving on to the examples. The first one is to find the center and the radius of a circle given the equation like this. Okay, so for center, we need to find our G and F. Let me go back a little bit here. So in my general equation, I've got 2gx. Okay, so which means here I've got the 2gx equals to something that is x here, which is this one, 4x, equals to 4x. The x's will cancel, and this 2 is going to enter into 4 and give me 2. So which is my G is 2. Then for F, I've got the 2Fy, which is equals to what? This guy here. Take note of the sign, which is a negative 3y. The y's will cancel, and this 2 is going to divide there. I'm going to get my F equals to negative 3/2. So for my center, I said my center is what? Is negative G and negative F. So coming back here, it means my center is negative 2 and positive 3/2. So this is the coordinate for the center. Then for the radius, r equals to square root of g squared. My g is 2, so 2 squared plus negative 3/2 squared minus my c. My c is negative 7, so it's minus negative 7, like this. Then I put in my calculator to get a square root of 53/2. So this is my answer there. Then moving on to number 2. This is actually from Zimsec. Write down the equation of a circle with center, this one, and radius. So I'm given the center and radius, so I'm just going to say x minus 4 squared plus y minus negative 3, which is plus 3. So squared equals to r squared. Our radius squared is 25. So this is the answer for there. Then number 3 is a pretty tricky one. The line L1 has the equation, that one. So let me write it down. I've got line L1 having the equation 2x plus y equals to 8. The line L2 passes through the point. Then we have another line L2 which passes through the point A, which is 7, 4. And this L2 is perpendicular to L1. That means we have got M2 times M1, which is negative 1. So the question wants me to find the equation of L2. So to find the equation of a line, I need a point and the gradient. I'm already given 1 point here, but I don't have the gradient. But I can find that gradient from here using the gradient of L1. So let's find the gradient of L1. Let me use a color. So if I make this one into y equals to negative 2x plus 8, I can notice that my m1 is now negative 2. So if I say m2 times negative 2 equals to negative 1, it means my m2 equals to 1/2. So I have the gradient for m2 and the point, so I now come and say half equals to y minus 4 over x minus 7. Now I'm now having my equation. All I need to do is arrange it correctly. So let's arrange it. I'm going to cross multiply there and have x minus 7 equals to 2y minus 4. So x minus 7 equals to 2y minus 8. Then rearranging, I've got x minus 2y equals to negative 1. So this is the equation for L2. That's just how simple it is. We're using those properties on top. So we are done with this very short one. Right, we are back and we are starting on the topic of trigonometry. So we are going to start with the plane trigonometry, which is also referred to as circular measure. So in this topic we are talking about a new unit, which is the radian. This is its sign there, or its symbol for the radian. So this unit is used for measuring angles, just like the degree, and it is related to the degree in this manner. 2 pi radian is equals to 360 degrees. Okay, so using this relationship we can be able to change from degrees to radians. Then we have our circle here. We need to recall this terminology. So here we have what we call a sector, like this. Then here, if you have a chord here, you have a minor segment and a major segment. So this is simply what we have there. Then we move on to small angle approximation. So we have sine approximately equal to its angle theta. So what is happening with these things here is that we are saying that as our angle theta is very small, we are talking about theta in radians. When our theta in radians is very small, it simply means that sine theta is approximately equal to our theta. So this comes from this. We know that the graph of sine is like this. So if our theta is here, it follows that theta is almost equal to sine theta. So that's where we're getting this one from. For tan it's the same story. Then for cos it's a bit different. It's 1 minus theta squared over 2. But these are like some kind of formulas that you need to understand. You just need to cram and write them in your notes. You need to remember this. Then after this we are moving on to the calculations. So for calculations, an important note here is that our theta now is in radian. That's why we talked about the radian when we're starting. Our theta is in radian. Okay, so two things here, and we're given their formulas. We have the arc length. So given a sector like this, this is the arc length that we're talking about here. Some kind of perimeter, outside perimeter, or the curved part. That's the arc length, which is given by r theta, where r is our radius and our theta is the angle at the center measured in radians. Then to find the area of a sector, you use this formula, which is half r squared theta, where our r is the radius and our theta is this angle here at the center. Okay, so let's just do one example just to have this one sink in. So the question says, the diagram shows a sector of a circle with center O and radius of r. The length of the arc is equal to half the perimeter of the circle. So the length of the arc, this one here, let me donate it by S and write it here. S equals to r theta is equal to half the perimeter of the sector. So the perimeter, we're talking about all of it here, of which it is equal to this S plus R plus R. So our P equals to our S plus 2R, which is equal to R theta plus 2R. And they are saying that this S here is equal to half of P. So that means we have R theta equals to half of my P, which is the R theta plus 2R. So if I cross multiply and multiply everything by 2, I'm going to get 2R theta equals to R theta plus 2R. Moving that R theta to the other side, I've got R theta equals to 2R. Then the R's cancel and I remain with my theta equal to 2. So having my theta, I can now find the area, where A equals to half R squared theta, which is half R squared 2, which is equals to just R squared units squared, like this, because they said find the area of the sector in terms of R, and this is what we did here. We've got our answer in terms of R. This is sequence and series. Under this topic, we are looking at the definition of a sequence, which is a list of numbers that are arranged in a specific order, and we have a way of calculating the next number in that list. Then a series is the addition of the terms or the values in a sequence. A sequence has a number of behaviors. By this I mean, like, for example, the example that I have given here, we have 2 at the start and 10 at the end, so which means we are getting higher and higher as time goes on. So this type of behavior is referred to as divergent. The numbers are increasing with time. Oscillating, we're saying that maybe our first number is positive, then our second is negative, and so on. So it's oscillating between positive and negative. Then our next one is periodic. Periodic, we are saying that it is repeating. For example, you have 1, 0, 0, 1, and so on. That is periodic. Then lastly, we have convergent behavior. Convergent, we are decreasing as time goes. So we have maybe 10, 8, 6, 4, 2, and we're getting smaller and smaller. So these are going to be used in this topic a lot, so I want us to talk about them. So this Tn like this means that it is our nth term. Then A means the first term. Then N is the number of terms. Then D means the common difference, which is the difference between here, here, and here. That difference is going to be common. Then R means the common ratio. This one applies to those that do not have a constant difference between the elements. Then you have Sn. This is the sum of n terms. Then sum to infinity is the sum for an infinite number of elements. The convergent behavior gets smaller and smaller with time. So if you take an infinite number of terms, you will find what we refer to as the sum to infinity. But what is important here is the calculation of the sum to infinity. Nobody will ever ask you to explain what sum to infinity is. Then we have two types of sequence. The first one is the arithmetic progression. This is the type in which the difference between a successive elements is constant. Here the difference is 2, here 2, and here is 2. So this is abbreviated by AP. And the other one is geometric progression. This one, the difference between successive elements is not the same. The formula for calculating the next term is this one here, where A is first term, R is the common ratio, N is the number of that term, or for example here this will be, our N will be 3 if we want to find this 8. Then for AP we have first term N minus 1 times common difference. So these ones, they're just very simple. Like, what you should know is to know these formulas. Just know these formulas and you'll be good. Then we're moving on. This is a new terminology that we are not familiar with from any other topic, so I decided to explain what something like this means. So this is the summation sign, and it means adding everything. So if you are given it like this, we are adding everything from when this R is 1 to when this R is 4. For example, if we have it like this, it's same as this 2 times R is 1 plus this 2 times R is 2 plus this 2 times R is 3 plus this 2 times R is 4. This is what I wrote here. Then I simplified it into this. So here you are going to add this one and find your answer here. Maybe I don't know what the answer here is. You just do on the calculator. That's what this one means. Then for our number 2, we have N and this inverted I here. This inverted I is referred to as the factorial, and given an example as 6 factorial like this, it means you start with 1 and multiply with the next one until you get to 6. So it's 1 times 2 times 3 times 4 times 5 times 6. So this is what this means, and usually it's going to give you a very large number. Then we have this arrangement here. So this is also a new terminology that is used in the topic of binomial expansion. So this is the next topic down here. So these things are calculated from the calculator, and I want to show how you punch this to a calculator. So this and this mean the same thing. Some textbook will write it like this, others will write it like this, but it means the same thing when you want to punch this. For example, if you want to punch maybe 6, choose maybe 2 like this. You come to your calculator, you press your 6, then second function 5, because you want to use this. I'm sure you know, if you want to use the yellow things on your calculator, you press the second function. So that's why if I want to punch this on a calculator, I press 6, second function, then 5, then 2. If I press equal, it's going to give me the value for this. So that's how you do it on a calculator. We were talking about the sequences on top of the AP and the GP. We talked about how to find the terms. For example, if I put 1 for n here, I'm going to find the first term. If I put 2, I'm going to find the second term, and so on. Here, if I put 2, I will find this, and so on. So notice that I'm not finding the sum of 2 plus 4. I'm just finding this specific term or this specific term. But here now, we are now talking about the sum. So for sum here, if I put the maybe 4 here, I'm looking for the sum of the first 4 terms of that sequence. So this is the formula for doing that. Then for our GP, this is also the formula. Then this formula changes depending on whether your R, this common ratio, is greater or less than 1. So these are formulas that you need to also cram. I told you the strategy for actually cramming formulas. I said you list them at the back of the book so that it is easy for you to familiarize with them, unlike putting them in the notes along with the examples, diagrams, and other things that will distract you from actually seeing the formula when we are starting. And still on GP, we also have the sum to infinity. The sum to infinity is only available for convergent sequence where our R is less than 1. If we come here, it's the power of n. So if our n becomes very big and our R is something that is less than 1, like maybe a half or a quarter, I'm pretty sure you know that if you say a quarter to the power of 100, you're going to get a very, very, very small number. So we're getting smaller and smaller and smaller. So that's why the sum to infinity is available for when our R is less than 1. Then now we are moving on to the series expansion, which is also referred to as the binomial expansion. What this topic is all about is to just expand. Maybe a given 2 plus x to the power of 6, and they tell you to expand this. Unlike maybe 2 plus x to the power of 2, this one we can just do very easy. But if it's the power of 6, it becomes tricky. That is where binomial expansion comes in. So this is the formula for doing that. So we're saying given that a plus b to the power n and asked to expand in ascending powers of x, we're simply saying ascending powers of x, we are saying like x squared, x cubed, x to the power 4, and so on. So you can be asked a question like this, and if your question is like this, we are going to expand it like this. This is the formula for expanding. This is the choose function here. These are choose function, and here is n 0, then your first value here, which is a, then your second value, which is b. So I'm not going to read this formula. It's a formula that you need to also claim. But the key takeaway here is that this thing is only for n is an element of positive integers. By positive integers, we are saying all numbers that are positive. Maybe 2, 4, 6, 8, and so on. Those are positive integers, and this formula is available only for them. Another common thing that they might ask you is to find maybe the third term or the fourth term or the 10th term. For example, given 2 plus x to the power of 20, then they tell you to find the 10th term. You cannot expand this thing, but you can just find the 10th term directly from this formula, because you know that my first term has 0 here, my second is supposed to have 1 here, my third is 2 here, and so on. So it is easy for you to find the 10th term. So you can use something like this, knowing that your 10th term is going to have 9 here, 9 here, your n is 20. Then another one is this one. This is another method, but this method is universal. It is available for n is an element of real number. Whether your n is a fraction, is a negative number, is a whole number, or whatever, this method will work. But it is a prerequisite that you should do. If you are given something like this, it won't work. You need to rearrange it into 1 plus something, and that something is supposed to contain x. For example, if I'm given this one here, 1 plus 2x to the power of half, this 2x here is taken as this x here. Then if I'm given a plus x like this to the power of n, I need to factor out my a to outside to the power of n, then put a bracket like that, have 1 plus x over a to the power of n. So all these things, there are some kind of notes. They are not things that I can really explain. They are easy for giving someone as a note. These are things that you're supposed to store in your formula page. They are things that you're supposed to remember. They're not hard. You just have to remember them. Okay, so these notes that I'm writing here, they will be available. If you want them, you can get them. Then another thing here is the Pascal triangle. So these are many ways of expanding some things, but the Pascal triangle and that number 1 are only for positive integers. The 1, 2, 3, 4, 5, the positives one. But this one at the center, that number 2, is for everything, provided that you are able to put it in this form. Then let me explain the Pascal triangle. So the Pascal triangle comes from this idea here, that if I give you maybe x plus y, then I square it, I expect you to expand this one and get x squared plus 2xy plus y squared. So the coefficients there is 1, 2, 1. Alright, then if I tell you to do x plus y cubed, you are going to get your coefficients arranged in a manner 1, 3, 3, and 1, like this. So the Pascal triangle tries to, in fact it does not try, it gives you these coefficients. So here, if your n, this n here is 3 here, you have got these coefficients here. If it is 2, you have got these ones. If it is 1, you get this. If it is 0, you have that. If it is 4, you have got these coefficients. Then maybe the big part here is for me to teach you how you get these, because the point of the Pascal triangle is for you to get these. So let me show you how you get them. Alright, let me just erase it and restart. Alright, so when our n is 0, anything to the power of 0 is just 1. Then when it's 1, you put 1 there and 1 there. When it's 2, you just put 1 first, then you add these ones. You then add these 2 here, which is give you 2, then you put 1 there. Then for 3, you put 1 at the sides there, then you add these ones here, they will give you 3. Add these ones here, they give you 3. Then for 4, you put your ones outside there, then you add these, they will give you 4. Add these, they give you 6. Add these, they give you 4. So this is what we have here, and you do that until you get to your n equals to 8, 9, and so on. That's what the Pascal triangle is. But on this one, I'm going to do an example because it is a bit tricky. It's not as straightforward like others. Then we move on to the standard results. So the standard results, when we're talking about that summation there, we noticed that it is hard for us to, in fact, let me go back and show you what I mean. If you are here and then maybe this value here where there's 4, we just put maybe 200 here, and I'm supposed to do this for 200 things, so that is going to be tricky. That is why there are known formulas that work. For example, these standard results here, if we have r equals to 1, then n, then r like that, you can simply put your n here. So which means I'm going to put my 200 there over 2, then times 200 here plus 1, like this. If I do this, I'm going to get the solution for here, or the sum. Yeah, in fact it's the sum. And then for this type and this type, these are the expressions for the sum. So these are standard results. I'm going to show you how you actually use them, but these are another things that you're supposed to write at the back with your notes and cram them. Then also have the Maclaurin series. For now, you will not really get what it means because it is talking about a topic that you have never heard of, differentiation. So the Maclaurin series, you can just copy them to your notes, and the Taylor series, you just copy to your notes. These are not really necessary for now because you don't know what these dashes mean here, and even if I try to explain, you don't know what differentiation is, you don't know what is the first derivative, you don't know what is second derivative, so it's pointless for now. So these ones, have them in your notes, but wait, we are going to really explain later what we mean by this value, this value, this value. Okay, then we go to my favorite part, doing the questions. So our first question here, it is saying the first term of HGP is 81 and the fourth term is 24. Then we are supposed to find the common ratio of this progression. So we're told that our first term A equals to 81, and then our fourth term, so T4 is equals to 24. The formula for finding the fourth term is given by what? T4 equals to A R, then our N is 4 minus 1. So which means our 24 equals to A R to the power of 3. Okay, we know that our A is 81. So 24 equals to 81 R cubed. What we want to look for is that R, which is our common ratio. So we can divide everything by 81 and we are going to get our answer as 8 over 27 equals to R cubed. And if I take the cube root both sides, I'm going to get my R equals to 2 over 3. So this is my common ratio there. Then next I'm supposed to find the sum to infinity. So sum to infinity is something like this: A over 1 minus R, which is 81 over 1 minus 2/3, and on a calculator is going to give me 243. So this is all about this first question here. We can move on to the second one. The second question says expand 1 over square root of 4 plus 3x in ascending powers of x up to and including the term x squared, simplifying the coefficients. Okay, so we're supposed to expand this guy here, which is 1 over square root of 4 plus 3x. Okay, so this is same as 4 plus 3x to the power of negative half. Okay, and I said if it is 4 here, we need it to be 1 plus something. So this is same as 4 to the power of negative half times 1 plus 3x over 4 to the power of negative half. So 4 to the power of negative half is what? Is the same as half, like this. Then open brackets, then I said 1 plus nx, my n is negative half. So now I'm following that formula there, and then my x is what? 3x over 4. Then next is plus, my n is negative half, then my n minus 1 is negative half minus 1, which is negative 3 over 2, like this, over 2 factorial. Then my x, which is 3x over 4 squared, like this, close bracket, because we are told that up to and including the term x squared. So we have reached our x squared there. So here we are going to have half, then we've got 1 minus 3x over 4, then plus a 0.5 or minus 0.5 times minus 1.5 times 33 squared, which is 9, over a 2 times our 4 squared, which is 16, then times our x squared, like this. And this, if I simplify on a calculator, I'm going to get half 1 minus 3x over 8 plus 27 over 128 x squared, which is same as half minus 3 over 16x plus 27 over 256 x to the power of 2. So this is my answer there. This is the answer there. Okay, then we can move on to the topic of summation. So I cannot call this one a topic because we are just revisiting some stuff that we were doing, but that's where we have examples that are specific to summations. So here I found this a screenshot from some of the textbooks, and it summarizes a lot of stuff here. So they are telling us that if you are given a summation question like this, r equals to 1 here, then n there, then here you are like this. Your first question is ask, is it an AP? How can we check that this guy is an AP? The answer is simple. You do your r equals to 1 and then you get your value, maybe u1. You do your r equals to 2, you get your u2. You do your r equals to 3, you get your u3. Then if you have 3 values, or you do maybe you have 4 or 5, you then check the difference between them. Is that difference constant? If maybe that distance is constant or is 2 between all values, you know that it is AP. So it will be a yes. That's why you use this formula here. We have talked about this formula here. This is formula for finding the sum of terms of an AP. If it is a no, we check, is it a GP? By the same method that I was telling you that you do for R1, R2, R3, and then R4. Then you check if it is GP. How do you check that something is GP? For GP, you divide. You don't check the difference. In order for you to find the common ratio, maybe you have term 1, you have term 2, you have term 3, you have term 4. If you want to find your common ratio there, you say term 3 divided by term 4, then term 2 divided by term 3, then term 1 divided by term 2. If you get the same value there, it is a GP. For AP, you find the difference between term 1 and term 2. For AP, you divide. I hope it is understood there. So if it is a GP, you use the formula there. This is the formula that I gave you. This one here, you use it. Then if it is not an AP and is not a GP, you then ask yourself, is it made of these guys here? This one, we have r squared and r cubed. These are part of the standard results. You remember the standard results. If it is made of these guys here, you use the standard results. If it doesn't have this one, which means we are now using the method of differences. So the next thing that I'm going to do is to demonstrate this method here and one of these two here, and then the method of difference. Then this is another question from Zimsec in 2003, and in this one I'm given this. So first I'm going to do trial and error to check if it is GP or AP, or is not either GP or AP. So I'm going to try GP or AP method. So I'm going to say when my R equals to 1, what is there? So here if I put 1 there, I'm going to get 2 minus 3, which is a negative 1. So here is negative 1. If my R equals to 2, it's going to be 1. If my R equals to 3, it's going to be what? Going to be 3, and so on. So which means the difference here between these ones is 2, then between this one is 2. So this one is an AP. Okay, so it's an AP, and my first term is negative 1, and my common difference equals to 2. Okay, so which means I can find my sum easy. So sum of 200 equals to what? I'm saying sum of 200 because here is 200. So that sum is going to be what? It's going to be n over 2, which is 200 over 2 times 2a, which is negative 2, plus n minus 1. My n is what? 200 minus 1 times d, which is 2, like this. So I'm going to get 100 multiplying negative 2 plus 199 times 2, which is going to be equal to 100 times negative 2 plus 398, like this, which is equal to 100 times 39,600, which is what? 39,600. Okay, so this is our sum here using the AP or GP method. But since this one is also made of the R, I can also use the standard results method just as a way to demonstrate how the method is done. Okay, so I'm given this here. Here is 2r minus 3r equals to 1. Okay, so this one I can rewrite it as r equals to 1, 200 of 2r minus r equals to 1, 200, then here is a 3. It is possible to do these two, the summations. Then I can also take these two outside and have my expression as 2 r equals to 1, 200 minus 200 here, 3, then r equals to 1. Alright, now when I'm here, I have my 2 times, then this guy, this one, it's a standard result, so I can check it out. It's this one here, so it's equivalent to this one, n over 2, n plus 1. So I come here and say n over 2, n plus 1, like this, then minus 3 times 200. Okay, so here if you have something like this that does not have an r here, your answer is just this one times this one. So this is what I have, which is equal to 2. In place of n, I'm putting 200 over 2, 200 plus 1 minus 600. Okay, so this is going to be 2 times 100 times 201 minus 600. Okay, so this is going to be equal to 2 times 20, 100 minus 600, which is 40, 200 minus 600, which is equal to 39,600 on a calculator. So as you can see, this one is same as this one. these are two different methods of approaching it. Okay, then as promised, I said I'm going to do one of these two, the standard result. Now what is left is the method of difference. So the method of difference is used on the summation questions that cannot be converted to GP or AP and do not have standard results in them. So let us do the method of difference. So I put an example there. So given something like that, first you need to simplify that one by doing the partial fractions. So let us do that. We have got 1 over r plus 1 to partial fraction. I have got a over r plus b over r plus 1, then 1 a r plus 1 plus b r. If my r equals to 0, I have got 1 equals to a. Then if my r equals to -1, I've got my 1 equals to negative b. Thus b equals to -1. So I can rewrite that one is same as here. Now we're now putting the partial fraction there. Let me put it here first. Our a is 1, then our b is -1. So this is what it is. So here you've got 1 over r minus 1 over r plus 1. So we have some kind of difference there. So now let us do the method of difference. So for method of difference, you do a number of trials. So these trials, you say when r equal to 1, then you put your 1 there. You're going to get your answer as what? 1 minus half. Then you say plus, when your r equals to 2, we are going to get what? Half minus a third plus, then when r equals to 3, we are going to get a third minus a quarter plus. So here we are going to do this until we get to a point where our r equals to n. If you look at here, here and here, you're going to see that this point is supposed to be something like this: 1 over n minus 1 over n plus 1. I hope we can see this relationship. So I'm getting this one here, I'm getting from here, here and here. It is some kind of a pattern. So now, since these things are adding here, because I'm supposed to add everything for r equals to 1 to r equals to n, and I'm adding, but these guys here can cancel these ones. This one are subtracting and giving us 0, this one are subtracting and giving us 0, and so on. So as a result, it means this one is also going to not be there, but those that remain there are these ones. This one here is not being cancelled with anything, and this one, the last one, remain. So what we end up having is this 1 minus 1 over n plus 1. So this is our solution, this one. All we have to do now is to just simplify it. So let's simplify it. Our common denominator is n plus 1. Then this side we've got n plus 1 minus 1, which is going to be what? N over n plus 1. So this is the method of difference, which means if you are given your n there as a 200, you're now putting a 200 there and getting your answer. So this is all about the method of difference. A number of questions on this topic are very common, and if you check my past exam papers, you will see tons of these questions, tons of sequence and series there. We are now moving on to trigonometric functions. So let me get started here. So earlier on we talked about the radian. So here it is essential to be able to know what these common angles like 90, 180, 270 and 360 are in radians. So that's why I was just putting this, so that you know that 90 is pi over 2, 180 is pi, 270 is 3 pi over 2, then 360 is 2 pi. So typically when you're dealing with these trig functions, you're going to be drawing your Cartesian plane like this, then 1 here minus 1 here, then you start labeling. Either you are labeling in degrees, which are these ones, or you are labeling in radians. It's also going to give you the same thing. Okay, so with that one cleared out, now the next step is to talk about the actual graphs of these trig functions. So every graph that we are going to discuss here is important, and you need to be able to sketch this graph. So first we're looking at y equals to cos theta. This can also be y equals to cos x. This here is what is on the x-axis, and this y is in the y-axis. So the Cartesian plane is labeled like this, from negative 2 pi to 2 pi, then there is 0 at the center there. So this is same as 0, 90, 180, 270 and so on. So the graph for cos and sine are identical, but the only difference is that the cos crosses 0 at 1, then the sine crosses 0 at 0. So if you look at the cos and then look at the sine, it's like the sine is just taking the cos and moving it about what, and moving it 90 degrees backwards. Like that translation that we are talking about there, we are simply translating this purple one by 90 backwards, and you're going to get your cos. So it is also important to understand the relationship between this one and this one. Okay, so just know this, that your sine passes at 0, then your cos passes at 1. So the best way for you to understand these things and decrim these things is to actually sketch them yourself. If you sketch, you're going to see the relationship between them. The relationship is what allows you to grab something and keep it in your head. So doing these things yourself gives you that opportunity to notice patterns and the links or relationships between stuff, and that will make you to never forget. The tan, it is these lines here at 90 and 270. Then for the negative side is also the same thing. Then we just draw like this. So like I said, these things you need to do it yourself. Then when we are done with the cos, sine and tan, we now need to also know the 1 over cos, 1 over sine and 1 over tan graphs. So this is what we are coming to next. So this is the graph here for 1 over sine theta. So 1 over sine theta has a special name which is called cosec theta. So this is the graph for cosec. Then 1 over cos is here, which is referred to as sec. Then we also have 1 over tan, which is also referred to as cot. Okay, so you need to know this, and you need to experiment with these graphs in order for you to grab them. So after this graph, we are moving on to the identities. These guys are a very big part of this topic, so you need to pay attention and know this relationship that I'm going to show here. Okay, so here we have what? We have tan theta being the same as sine theta over cos theta. Okay, then cosec we have already said is 1 over sine. Then sec we have already said is 1 over cos. Then cot we have already said is 1 over tan, which also implies that you just invert this one and get cos over sine. So these ones need to be in your head, not in your notes but in your head. These are the most basic identities that you need to know by head. Then we also have this one we have seen it, I have talked about it, and this one is also supposed to be in the head because it is very important. These ones are also another identities, but they are not very commonly used, so this one can be in the notes and be recalled when you're going into the exam, but this one and these ones on top should be in the head. Then these ones also are supposed to be in the head. The sine 2 theta, cos 2 theta and tan 2 theta. So for sine 2 theta we have 2 sine theta cos theta. Then for cos 2 theta we have cos squared theta minus sine squared theta. And you can actually replace maybe this cos by this cos. If you want this one to be in terms of sine squared only, you can substitute here. You can use this equation to actually substitute for this one. Then for this one also, it's like this. Here it's supposed to have a theta there. Okay, so this need to be known. The reason why I'm saying these identities need to be known, they are the framework of everything that is going to be done here on this topic. So if you don't grab these ones, you are just wasting your time. Then also these ones also need to be known. This one, all these ones need to be known. Then after we have these ones, you can now start the real data of this topic. So the advice here, the best way to grab these things is to write them down. In fact, in your notes, if you have your maths notes, I recommend that you have maybe at the back of your notes, you're supposed to have a list of these identities and the formulas, because if you just put them in the book there where there are notes and examples and stuff, you will not have enough time to look at them. So you need to group them at the back of the book there, so that you have time to look at them as individuals, which will make it easy for them to sink into the head. So now we can move on to the examples. So the examples here is from Cambridge, which says prove the identity. Okay, so want to prove that this side is identical to that side. So these types of questions that require proving, you're supposed to start with the side that is more complex, going to the simple one. If you start here, you won't be able to really go here, because the side is a simplification of this one. So you need this one to get there. So I'm going to demonstrate how it is done. So first, you say your left hand side equals to cot theta minus tan theta. This is the left hand side here. So when we are here, you then come and say equals to our cot. We said it's the cos theta over sin theta minus our tan, which is sin theta over cos theta. So to solve these things, you typically convert to sin and cos, because they are the most simplest ones. So you are working with sin and cos. Then you now solve this one by finding the common denominator. Common denominator there is what? It's the sin theta times cos theta. That's our common denominator. Then if I say sin into that, I get cos times that cos. On the numerator there, I get a cos squared theta minus, then cos into denominator there, I get sin, then sin times that numerator, I get sin squared, right? Then next, we are now looking at this guy here. This guy is similar to this one here. So we are now replacing this one with this one. Okay, so here we've got cos 2 theta over sin theta cos theta. Okay, our next step now, if you look at here, we are trying to get to this one, so which means we need to have some kind of 2 multiplying here. Okay, so what you can do now is to recognize that the denominator here is missing 2 in order for it to be sin 2 theta, because on the denominator here we are looking for sin 2 theta, so that when we divide this one we'll get cot. Alright, so let's do it. We are taking the numerator and say 2 times our numerator, which is the cos 2 theta, over 2 times our denominator, which is sin theta cos theta. So this step of multiplying the numerator and denominator is called rationalizing, and it does not have an effect on the fraction, because these ones can also cancel like this. So you can do this to try to manipulate and get what you want, because this action is mathematically correct, so we are not breaking any rule there. So next here we are getting our 2 cos 2 theta over 2 sine theta cos theta. And this one, we recognize this one as this one here, as this one here. So we're now putting this. So getting back here, we are now getting our 2 cos 2 theta over sine 2 theta. Then cos over sine is now what? Our cot. So our answer now is going to be 2 cot 2 theta. Then we now say which is equals to right hand side. So this one is shown. This is how you do this one. So if you do that, you'll be done there. Then our next one is this one. You're supposed to prove that this one is equal to that. Okay, so looking at this one again, this side is more complex. This one is simplified. So we need to move from here to there. So we come here and say left hand side equals to sec 2 theta plus tan 2 theta, like this. So what is our sec? Our sec is 1 over cos 2 theta plus our tan 2 theta is what? Is sine 2 theta over cos 2 theta. Then our next step there is to add these numerators because the denominators are the same. So we've got equal to cos 2 theta as our denominator, then 1 plus sine 2 theta, like that. Then now we need to remove the 2 theta because our what we're looking for is theta, not 2 theta. So let's try to eliminate the 2 theta there. So we are going to have 1 plus 2 sine theta cos theta over cos squared theta minus sine squared theta. Okay, that's what we have now. So now we need to think and know what we are trying to find, which is this one here. So if you look at that one, we can replace 1 with this identity here, this one here. In place of 1, we can just put this one here. So let us do that. So now it's now equal to cos squared theta plus sine squared theta plus 2 sine theta cos theta all over cos squared theta minus sine squared theta. Okay, then if you look at the one on top, it is the same as something like this. Let me write it in red. It is same as something like x plus y squared. If you expand this one, you're going to get x squared plus 2xy plus y squared. So looking at the one on top like this, you're taking your cos as x and sine as y. So this is the situation on top. Okay, so here is equal to what? Our cos theta plus sine theta squared, just like I explained here. That's what we are now doing for our numerator. Then the denominator is the difference of two squares, so which means we can write it as cos theta plus sine theta times cos theta minus sine theta, like this. Then look here, this one can cancel this square here because we have two of these, so one of them cancel and we remain with the one. So which means what we are left with here is now cos theta plus sine theta over cos theta minus sine theta, which is equal to our right hand side. So this one is what is shown or is proven. So this is the answer there. Then the next thing is the trig equations. So these ones are very simple, but the problem is finding all angles, because alright, let's just do it. I'm going to show you why. Okay, so first we need to define two things here, which is the primary value and the secondary value. So the primary value is simply the first value that you find when you do your when you calculate using a calculator. For example, if you're given an equation like this and then you are now finding your theta, you do this arc sign with a -1 there, and then your first answer is going to be 30 degrees. In radians, it is going to be pi over 6. So this is what we call our primary value. So this primary value can be found for both the tan, the sine, and the cos. Now that we know what our primary value is, we can also know what is the secondary value. So the secondary value is only essential for the sine. We are going to calculate the secondary value for the sine only. The others do not need the secondary value. So this is the obtuse version of our primary value. Look what I mean here. This is the first one that we had. You do your arc sign here, then you get your primary value here. After doing that now, so I'm going to illustrate this on the graph, because if you say sine theta equals to 0.5, you are simply saying that your graph is here. So you are drawing a line like this, so you meet the curve there and you have your 30 there as your primary value there, but the line also touches the graph there, and this is the obtuse angle. So this obtuse angle is what we call the secondary value. For cos, this angle is going to be negative. Let me show you on the cos. Let's look at the graph for cos. So for cos, for sine, you're going to get a primary value here and then get a secondary here, like this. But for cos, if you get here, you also get the same one, but which is negative, like this. I hope it's clear there. Okay, so now that you understand the primary and the secondary values, we can proceed and look at how to find other angles. Alright, so let me explain why we are going through this trouble. So the trouble that we have, we will be given an equation like this, saying solve the following equation, and they are saying that tan 2 theta equals to 1 for theta is in the range 0 to 18. if you do this on a calculator and say arctan of 1, you're going to get your answer as 45. Okay, so which means you're going to get a 2 theta equals to 45 like this. You can, if you look at this carefully, you think I can just say theta equals to 45 over 2, and that is going to give you a 22.2 degrees as your answer. But the problem now is this. If you look at the graphs here, the graphs repeat a lot. So if you say this is 1 is going to give you this value, then okay. But if the range that they have given you is very long, which means you also need to calculate this value again, and you need to calculate this value and this one. So that's the problem here. Your calculator is going to give you this value, but this one it won't give you this value, and it won't give you this one and this one. So that's why we are going through the trouble of trying to find others, because your calculator can give you here, but you also need to find this one, and you also need to find this one, because you have some kind of line here. So everywhere where it touches your purple line is a solution. So you need to know all these angles. You need to give us 4 angles there. I hope it's understood. Let's move on. Now that we know why we're doing that, for sine, if you do an arc sine and find your angle, the primary value, you come and put your primary value here and say plus 360n. Then you also find your secondary value, which you can find it by saying 360 minus primary value. And then you say on your secondary value, you also say plus 360n. This n is 0, 1, 2, 3, and so on. You're going to see this one when you are now doing an example. For cos, you take your primary value and say plus or minus, then you add 360n. For tan, just say primary value plus 180n. So let us do an example and explain whatever we are saying on top of there. So our first one is this one. We want to find the solution for the equation, which means we want to find theta. Okay, so let's do it. So 2 theta equals to arctan of 1. If you do on a calculator, you're going to get 45 like this, 45 degrees. Okay, so now the challenge is that we need to find other angles, because we don't know that in this range between 0 and 180 we have found all angles. So you need to make sure that you don't leave an angle behind. So what you do is now you take your 45 like this and say plus 180 n. Then you now say your 2 theta equals to what? If n equals to 0, you get your 2 theta is equal to if I put 0 for n there, I get 45. Then if I put n equals to 1, I get what? I get a 2 theta equals to 45 plus 180, which is 225. So it's going to be 225. Okay, since my range is this one, this 225 is already above 180, so I can stop for now. Now I need to find theta. Here theta is what? 45 over 2, which is 22.5. Then here my theta equals to what? 225 divided by 2 is going to give me 1, 1, 22.5. So my answer, the one that I write, is now theta equals to 22.5 and 112.5. So this is the solution for that equation. This is how you approach it. For tan, it is very simple. Alright, so this is our next question here. So this one is a bit complicated there because we cannot do the arc cos and arc sec of something. It is not easy like the ones that we did. So we need to simplify so that it is easy for us to do the arc tan of something, arc sine or arc cos of something. So to make it easy like that, we simplify. So we've got 2 cos theta minus 1 over cos theta equals to 1, like that. Our sec there is 1 over cos. Then we multiply by this denominator there. We have got 2 cos squared theta minus 1 equals to cos theta. Then moving this cos to that side, I've got 2 cos squared theta minus cos theta minus 1 equal to 0. Then now I can say let cos theta equals to y. Then I've got 2y squared minus y minus 1 equals to 0. Now I'm solving my quadratic for y. So I can solve it and say 2y squared minus 2y plus y minus 1 equals to 0. Okay, so here I've got 2y, then I've got y minus 1, then here also y minus 1, like this, plus 1 here equal to 0. So I'm going to get 2y plus 1 and y minus 1 equals to 0. So which means my y equals to negative half or 1, like this. Okay, so what is our next step? We can now come back and say cos theta equals to negative half or 1. So now it is easy for us to do the arc cos. So what we are going to do is take this one. Let me separate here. So we are going to say cos theta equals to negative half and say theta equals to cos to the power negative 1 of negative half, which is going to give us what? 120. So this is 120. This is our primary value, and for cos we say you do it like this, plus or minus 120 plus 360 n. Now if I say my n equals to 0, I'm going to get my theta as equal to what? 120 and negative 120. So negative 120, I don't want him because I'm given my range here. We start with 0 there. Then if I say my n equals to 1, I get my theta equals to what? If I take the positive and say plus 120 plus 360, I'm going to get something that is higher than 360, and I don't want that. So if I'm going to take the negative 120 plus 360, which is going to give me 240. Okay, so in this range that I'm given here, I have all my values. I can come now to say cos theta is also equal to 1, and my theta equals to arc cos of 1, which is going to give me a 0. Okay, having my 0, I can take 0 and say plus 360, and here plus or minus. Okay, so my theta now equals to what? If I say n is 0, I'm going to get my theta as 0. If I say n is 1, I'm going to get my theta as 360. So finally my theta now equals to 0, 120, 240, and 360. These are my answers for that equation. Alright, then the next one, number 3, we're given a different scenario here, which is 3 cos theta minus 5 sine theta. Alright, so this is a type of an equation, and it's right here. They're saying it is equal to 2. So unlike the one on top, here we have sine and cos. So having cos and sine here, you cannot convert them into all cos or all sine. So if you don't have a situation like that, you can do the arc sine or the arc cos so that you solve for your theta. So this is the problem here that we have. That is why this one is also another method which is referred to as the R formula. That is why we're supposed to express this one into this form here. This form here, we have R cos something. So if we look at this statement now, it has removed the sine. We now have the cos. So our aim here is to first remove the sine. So we remove it by saying R cos theta plus alpha, like this. Okay, now let's do the process of removing that sine. So to remove our sine, we need to find the value for R and alpha. So since this is an identity, we can expand this side here with an R using this trig identity here. We're using this one here, this one for expanding the sine, and this one for expanding the cos. So in this case we are dealing with the cos, so we're using this one. If you look, there is cos theta plus alpha. Okay, so we can expand it into this form here. Let us do that. So we are here. This is same as R cos theta cos alpha plus, no, it's a negative because it's the cos. So cos, you put minus there. Then we say R sine theta sine alpha. Okay, then now we now take the ones that have cos theta like this. So we now equate those. So the ones that have cos theta, the side, if I remove cos theta, I've got 3 equals to R cos alpha. Then now the ones that have sine theta, I've got 5 equals to R sine alpha, like this. Okay, so having this one, having these two, I can find my R and I can also find my alpha. So finding alpha, let me do it like this. So finding alpha, we can say equation 2 divided by equation 1, which is going to be 5 over 3 equal to, dividing this side, the r's will cancel, so we remain with the sine over cos, which is just tan alpha. Then now we find our alpha by saying tan to the power of -1 of 5 over 3, which is going to be 59.0. So we have our alpha there. Now we need to find our r. To find our r, we are going to use that identity. Let me write it here. We're going to use this identity, cos squared theta plus sine squared theta equal to 1. We're going to use this one, and we do it by squaring. We have that one, which is 3 squared equals to r squared cos squared theta. That's equation 1. Then we've got 5 squared equals to r squared sine squared theta, equation 2. Then we just add these ones. If I add there, I've got 3 squared, which is 9, plus 5 squared, which is 25. On the other side of equal sign, I've got the r squared, adding sine squared theta plus cos squared theta. So that's where this guy comes in. We now put 1 here. So I remain with the r squared equals to 9 plus 25, which is just 34. So my r is now equals to square root of 34. Okay. So the question did say that my r is supposed to be positive and my alpha is supposed to be less than 90, and that's exactly what I did. So it simply means that we have root of 34 cos 59.0 plus theta as our answer there. Then the question continues and says, hence or otherwise find the general solution of the equation, this one, giving your answer correct to the nearest degree. So we are just putting equal to 2 there. So we are saying root of 34 cos theta plus 59.0 equals to 2, like this. So I remain with cos theta plus 59.0 equals to 2 over root of 34. Then I do arc cos, so theta plus 59.0 equals to arc cos of that, which is what? 69.9. Okay, so to find others, I will say plus or minus 69.0 plus 360 n. Okay, then when my n is 0, I'm going to get what? I'm putting 0 here, so it's going to be 0 everything here. I'm going to remain with the plus or minus 69.9, which is just same as a 69.9, or negative. The negative part I don't need, because I'm already told my range, that my range is what? Right here I'm not given the range, but I'm assuming that the range of the values for theta is between 0 and 360. So I'm taking the positives. Okay, so I'm here. Then if I say my n is 1, I'm going to get another one, which is 290.1, like this. So this is equal to theta plus 59.0. Then now I'm now doing theta only and moving my 59.0 to the other side, which is going to be 10.9 and 231.1 degrees. So this is the general solution for that equation. So it is very important to understand the R formula. Okay, so let's go back and look at the identities that we used here. So I remember using this one here, this one we also used, this one we also used, and this one we used. I think we also used these two, and this one we used. We also used this one a lot. So as you can see, these identities are very important. They need to be known. I had forgotten this one was also used again. So it is very important to know those ones.